Okay. Now if I can share screen. Screen 2. That is not what I want to be sharing. This is how you know I'm technologically incompetent. Yeah. Give me one sec. I can't hear a single word you just said. Okay, can you see the screen? The chapter
Yeah.
1 summary review? All right. Perfect. Now we can annotate that. Is that working? No, it is not. All right, that works. Great. Clear all drawings. All right, let's start it with 1, right? Give me 1 second and we'll get my notes, and then we can do whichever problems you want. Okay. Do you want to start out with 1?
Let's go through one. Just all of them. I want like the most I can get out of this.
Okay. So we'll start with 1, just go through until we finish.
Yeah.
I'm just gonna see if I can move Microsoft Whiteboard to here. I hate technology. Sorry. Please move. Please. Can you see Microsoft Whiteboard on here?
Yes.
All right, and then we're gonna do split screen. Oh my gosh, I am sorry. I can't deal with technology.
You're good.
Okay. Great. Your whiteboard. Give it a second to load. Okay, and then we're not gonna annotate, we're just gonna use Microsoft Whiteboard. Feel free to use the annotate tool if you guys want to figure something out, or like I did something wrong and you need to fix whatever it is that I did wrong. Okay, starting out with the first problem. Wow, okay, I just suck at technology. That's nice to know. Okay, show that there are 2 geometric sequences such that the second term is 9 and the sum of the first 3 terms is 91. Write the 4th term of each sequence. Okay, so what am I supposed to use? That works, right? Okay, yeah, we'll just use that. Sure. Okay. So how do you think that you would approach this problem? Or do you just want me to go through the problem? Either one
I
works.
want you to go through the problem and explain every single step.
Okay, so I'll explain stuff and then I'll check in between, make sure that you follow. If you don't follow, just tell me immediately. Tell me wherever you stopped understanding. I'll go back from there and then we can work through there. Okay?
Yeah.
So there are 2 geometric sequences. The second term is 9, correct? So that means U2 equals 9. How do people write? Okay. And then the sum of the first 3 terms is 91, right? So U1 plus U2 plus U3 equals 91. Okay, sorry, give me 1 sec. I'm just gonna move this to the main screen and use the touchpad. I cannot. I tried, I swear. Or, you know what, whatever. As you guys can understand what I'm doing, right? Even if it takes a little bit of extra time to write.
Yeah, you're good.
Okay, so U2 equals 9, correct? U3 is going to equal 9 plus the difference between U1. Oh, wait, no, this is a geometric series. Never mind, ignore what I just said. U3 is going to equal 9 times the common ratio, correct? Because it's a geometric series. So in 3 numbers that are directly in order, there's going to be a common ratio between the first and second number and the second and third number, right? Like, Yeah, okay.
Yeah, I got it. I got it.
Okay, okay. And then U1 is actually going to be 9 divided by the common ratio because if you do U1 times R is equivalent to 9, right? All you have to do to find U1 is divide both sides by the common ratio so that you get 9 over R. Okay. So now you have 9 over R. Oh my God, no, stop it. Ah, what did I just do? 9 over R plus 9 plus 9R is equivalent to 91, correct? So what you want to do here, first, what, ignore. Okay, first thing you want to do is get rid of the 9 on this side, or another way you can do it is subtract 91 so that you have, you know what, whatever, we'll just start with subtracting 9. So you have 9 over R plus 9R equals, what is 91 minus 9? 82, right? Now, what you can do next is you can multiply everything by R to get rid of the R in the denominator over here, right? So then you get 9. Oh my God, work. 9 plus 9R squared equals 82R. Now, the next thing you would want to do is you see that you have a term that's A squared, you see that you have a term with A, and then you see that you have just a coefficient term. So what you can make this is you can turn this into a quadratic, that should be an 82. But you can turn this into a quadratic equation. Not a quadratic equation, a quadratic function. So you have 9R squared, 9R squared minus 82R because you're subtracting 82R from the other side, and plus 9R. Not 9R, 9R. Oh my God, sorry. You can tell I'm tired. Plus 9 equals 0. Everyone understand what's happening? Or do we have to go back a couple steps and then rework it from there? Just give me like a thumbs up and like reactions or something.
We're good, I think.
Okay. So, you can anyone do this off the top of their head? Because I know a lot of people can't. So, anybody? Great, no, okay.
9R minus 1 and R minus 9.
9R minus 1 and R minus 9. Okay, perfect. Minus 1 and R minus 9. Now, for those of you who can't do this, just stick with the quadratic formula, or if you have some other method that works constantly for you, stick with that and then just figure out what it factors out to or what your solutions are. Now, over here, this means that your solutions are either 9 or it's 1 over 9. Everyone see how we got that? And if you don't, please review algebra. Okay, so what we want to do here is we want to plug this into the equation for a geometric sequence, right? Because we want to find the fourth term of each sequence. So we're going to have u sub 4 equals 1, right? Everyone see how we got 1? Because 1 is going to be 9 over r. In this case, because r is 9, your common ratio is 9. That means that 9 over 9 is u sub 1, which means that your first term in the geometric sequence is 1. So everyone understand how we got that? I'm going to take that as a yes. Okay. So you have 1 times 9 to the power of 3, because remember the equation for a geometric sequence is u sub n equals u sub 1 times r to the power of n minus 1. So u sub n over here, you want to find the fourth term, so we have u sub 4 equals u sub 1, which is 1, times the common ratio, which we just found out for this case is 9, to the power of 3, because 4 minus 1, n minus 1 is 3. So now 9 to the power of 3 is just 729. So that is your first case. If you want to fully write this out, after you get r equal, please show up. R equals 9 and r equals 1/9, we want to take r equals 9 as case 1. So you solve for case 1. That should say case 1. And then this is going to be your case 1. So for case 1, you have 729 as your first term. And then for case 2, if I can manage to write case 2 any day soon. Okay, for case 2, we do the same thing. So u sub 4 equals 1. Again, u sub 1 is 1, therefore, or sorry, u sub 1 is not 1 anymore in this case. U sub 1 is 9 over 1/9. So if you want to find what the value of that is, you just multiply by the reciprocal of the denominator. So you get 9 times 9 over 1, which is just 9 times 9, which is just 81. So that should be 81, not 1. Ah. 81. And then again, you put in your common ratio, which in this case is 1/9. So 1 over 9 to the power of 3. Now this is something you can just plug into your calculator, and you would get, well, okay, you could plug it into your calculator, or you could do what I did. I saw that 81 is just 9 squared. So 1 to the power of 3 is just 1. So you have 9 squared times 1 over 9 to the power of 3, which is just 9 squared over 9 to the power of 3. Does everyone see how that works? If not, I can go back and re-explain all that. I'm going to take that as a yes. And then from here, all you do is cancel out 2 9s, and you're left with 1 9 in the denominator. So you just have 1 over 9 as the value for the fourth term in your second case. Good? Great. Well,
Wait,
yes.
can you explain how you got 9 squared over 9 to the power of 3?
Yes. Okay. Sorry, give me 1 secondo. Yoo-hoo. Okay, so I got 9 squared over 3. Ignore what I just said. I got 9 squared over 9 cubed because, okay, so 81 is what? 81 is just 9 times 9, correct? So that's just 9 squared. And then 1 over 9 to the power of 3 is 1 cubed over 9 to the power of 3, right? 1 cubed is just 1. So you have 1 over 9 to the power of 3. And 1 over 9 to the power of 3 times 9 to the power of 2, you can just, if you can't just look at that and add it, then, or not add, multiply. Another thing you can do is just do 9 to the power of 2 over 9 to the power of 2 over 1 times 1 over 9 to the power of 3, right? Now you multiply your numerators, you get 9 to the power of 2. You multiply your denominators, you get 9 to the power of 3. And then you just cancel out. You have 9 times 9 over 9 times 9 times 9. You can cancel out 1 9 from the top, 1 9 from the bottom, 1 9 from the top, 1 9 from the bottom. So all you're left with is 1 over 9. You see how I got that?
Yeah, I got it.
All right. So your answers to your first problem should be either u sub 4 equals 7. Well, you should have both. U sub 4 equals 729 and u sub 4 equals 1/9. Or you should actually technically write or because they're two separate terms. Okay.
Wait, so how did you do
Yeah.
the U4 part?
U sub
Like,
4?
I don't get how you got the first term.
Okay, so I did, you see here how we have u sub 1 times r equals 9 because the first term times the common ratio is going to equal your second term, correct?
Mm-hmm.
So I just plugged in what we already had for r. We got r for the first case, so I just plugged in 9 over here. So u sub 1 times 9 equals 9, correct? Or you
Oh,
could
okay.
plug it in here, and then 9 over 9 is just 1. So for this case, it's 1. And then for the same thing over here, you plug in 9 over 1/9, and then you just multiply it by the reciprocal to get rid of the fraction in the denominator. So you have 9 over 1 times 9 over 1, which is just 81, which is why in your second case, u sub 1 is 81. Got it?
Okay. Yeah.
All right. Everyone good? Yes, I can erase everything, hopefully, if I can figure out how. Oh, that works. Okay. Sorry, I suck at using technology. Just ignore me for a second. Oh, God. Just delete already. It's not that hard. Okay, now we are going to move on, if I can find it, to the next question, which is find the sum of the series 1 plus 2 plus 3 plus 4 plus 5 dot 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 plus 7 plus 8 plus 9. That should say plus 10 plus 11 plus 12 plus 13 plus 14 plus 15. I think what happened was because it's such a big textbook, the people who are writing it don't always pay complete attention to what they're writing, or they'll just see numbers all day long. So it kind of like all meshes into one. So I don't really think that they realized that they skipped a couple numbers, but just know that it should be like just a plus 1 and then b plus 1, so on and so forth. If I can get that to show up. All right, so what we're gonna do to find this is, everyone remember sigma notation, right? So we have sum from r equals 1, because your first term, to, or you could also write r equals 0, you just shift everything down 1, from r equals 1 to 64. Or you could write r equals at the top too, that doesn't change anything. Oh my gosh, stop it. Excuse me. So r equals 1 to, sorry, excuse me. The sum from r equals 1 to 64 of 1, which is your first term, plus, because remember, if you can look at this and immediately tell that it's an arithmetic series. Why? Because there's a common difference between each number. So find the sum of the series of this is just going to be 1, which is u sub 1, plus, does anyone remember the formula for your general term for the arithmetic series? Yes, no, maybe so. Oh, okay, you're the only one left, so.
U1 plus n minus 1 d, or like you can put it
Yeah,
in
d and
different
10
ways.
minus 1. But d in this case is just positive 1, so you don't have to write anything for d. You can if you want to, but it's not necessary. And then into n minus 1, right? Ah! Ignore the horrible writing. So that means that you have s sub 64, because remember, for the sum of an arithmetic series, you have u sub, or s sub n in you have s sub n equals, what was it? I can't remember off the top of my head. Like u sub 1, what was it? Do you remember? Because
Wait, what do you want?
the sum of an arithmetic series.
UN equals, wait, I have it. UN equals n over 2.
There you go. N over 2 times u1, u sub 1 plus u sub n, right?
Yeah.
Okay, so okay, n over 2 equals, what's your u sub 1? Not equals, I don't know why I wrote that. Again, I'm kind of out of it, but you have n over 2 equals, again, n over 2 times 1 plus your last term is 64. So u sub 4, or u sub n is 64. This is just 65. So 65,
65 over 2. I mean 64 over 2, right? Because n is 64.
oh, sorry, that should say 64 over 2. That's why I got confused. There we go. So you have 64 over 2 equals 1 plus 64, which is just 65. So what is 64 over 2? 32. And then you have 32 times parentheses times 65, which equals 2080. Any questions on this one?
Nope.
All right, let's move on to the next question, if I can manage to find it. Sorry, just bear with me. I suck at.
No, you're good. You're putting so much time and effort into this. I'm grateful.
Okay. Now. Sorry, I restarted my computer and everything just deleted, so I just stole my brother's computer.
Oh,
Fun. Okay. We have three numbers, A, B, and C form an arithmetic sequence. The numbers B, C, and A form a geometric sequence. So that means that A plus B, or A plus B plus C equals 36, and then B plus C plus A equals 36, which obviously. But then what you also have to think about is for the geometric sequence, you're gonna have your second, you're gonna have the second term of your arithmetic series be the first term of your geometric series. You're gonna have the third term of your arithmetic series be the second term of your geometric series, and then you're gonna have the first term of your arithmetic series be the third term of your geometric series, right? Because that's why it's in that specific order.
right,
So we
right.
have, well, thank you. We're gonna take B, right? So B is your middle term for your arithmetic series, plus. So then we're gonna have B plus D on one side to find C, because you see how I got that, right?
Yeah.
Okay. And then on the other side, you're gonna have B minus D. Okay. So all of this equals 36, correct? So what we can do here, minus D plus D cancel out, so you end up with 3B equals 36. So that means that B equals 12. You see how I got that?
Yeah.
Okay, great. Excuse me. So now what I want to do is I'm going to plug this into my, okay, so to find the sum of three numbers in a geometric series, instead of using the sum formula, an easier way to do it is just say A plus A times R plus A times R times R, so AR squared, equals the sum. Or if you want to write it like, well, that's basically what we're going to do. So in this time, for the geometric series, B is your first term. So you can write 12 plus, C is going to be 12 times the common ratio. So you have 12R, correct? And then A is going to be 12 times the common ratio, and then that entire thing times the common ratio. So just 12R squared. Good?
Wouldn't this be B, C, and the next one?
So see here it says the numbers B, C, and A. So it's saying that the second term of your arithmetic series plus the third term of your arithmetic series plus the first term of your arithmetic series is going to equal 36, and that's the order that's going to be your geometric sequence.
Okay.
Do you understand it or not really? We can go back and work it through if you need.
I don't understand how we got R and R squared, because those are like increasing. So A should be lesser than B, right?
Yes, but think about it. R doesn't necessarily have to be a whole number. R can be a fraction, and if R is a fraction, it's going to decrease, correct?
Oh, yeah.
So you see, yeah.
Okay, yeah, I got it.
Not necessarily even a fraction. If R is a negative number, you're going to be going down instead of up, unless you have negative 26 times something, which is going to go up and then down and then up and then down. You see how that's going to work?
Yeah.
Okay. So, and then you understand how we got 12 plus 12R plus
Yeah,
12,
yeah.
correct?
Yeah.
Ew, I don't like this light green. That's going to equal 36. So what I want to do, I'm just going to make this into, or you know what? I'm going to make life easier for myself. I'm going to divide everything by 12 because 12 is common in every single term in this equation. So I'll end up getting, if you will let me write, I end up getting 1 plus R squared equals 3. I'm going to move the 3 over to this side so I can make a quadratic equation. So over here, I'll just have R squared plus R. 1 minus 3 is just minus 2 equals 0. You can kind of look at this and just go, what two numbers make -2 that make +1? It's just +2 minus 1, right? So you have r plus 2 times, oh my God, work, r minus 1, right?
Mhm.
Ah. Oh, geez, do we have a charger here? Give me one sec. Okay, great. Where's my mouse? Okay, so that means that the two values for r is going to be -2 and +1. Correct. Ah. So it's the set of -2, comma, +1. That's just math notation. You don't have to write it like that if you don't want to. It is suggested that you write like that just so you can get used to the math notation, but if at least for right now, if it works better for you, not using it like that, just understand what is happening instead of having to write it perfectly. Okay, so what we have here, we have two separate cases because r can be -2 or r can be +1. What? Yeah, everything's good. Cool. Okay, so r can be -2 or r can be +1, right? So what I'm going to do is I'm going to plug the values that I got for r back into this equation over here so that I can solve where was I going with this?
Substituting negative.
Oh, yeah, so I'm substituting it back in so I can figure out the values for C and A. Sorry, I blanked out for a second. Can I move around? No. Yes, maybe. Maybe if I just do that. There we go. There, perfect. Okay, so what I'm gonna do is I have case 1. Remember how we talked about cases, where if you have two separate ways that it could go, you're gonna write case 1 or case 2. If you have multiple, depending on how many numbers, you keep going until you finish. So case 1, you have 12 plus 12r. R in this case is going to be -2, so you have 12 times -2 plus 12r squared. R squared is -2 to the power of 2. In this case, it's 4. So you have, oh my God, I hate writing with mouses, but you have 12 times 4, not 12 to the power of 4, 12 times 4. That equals 36. Ah. Okay, so we're just going to move everything to one side, and then we're just going to solve, okay? So if you move everything to one side, what you'll end up getting is 12 minus 24 minus 48
I think you mean 48.
Sorry, are you saying something, Seven? I can't really hear you.
Don't you mean plus 48?
Yeah, sorry. I don't know what I was doing in there or what I was thinking. But anyways, that and then minus 36 because you want to get the 36 over to one side. Or you know what? No, why am I doing this? I don't know why I'm doing that. Because you
by 12.
Yeah, you don't have to do anything of it anymore, right? Because you just got your values for C and A.
Oh,
I just realized what I was trying to do. But see, because this is your B value, this is your A. Oh my God. The second term in the geometric sequence is your B value, right? So 12 times -2, that means is going to be your B value. So your B value is -24. Oh my God, not B, C. Okay, we're going to start from the beginning, and then I'll explain it again. B, we already established, is 12, right? Over here, we established that B is 12. And then we also said that for the geometric sequence, it goes in the order of B, C, and then A, right? So then C in this case is -24. So C equals, I'm going to reset. C equals -24. And then A in this case is +48, right? So A equals 48. See, and then we already established what B equals positive 12. Now, you also have another case, right? Because r equals negative 2 or 1, correct?
Yeah.
Which, oh, please come back. Okay, which means that for case 2, oh, that one. Okay, that means for case 2, you have 12 plus 12, right? Because 12 times 1. And then plus, again, 12, because 12 times 1 squared is just 12 times 1. So 12 plus 12 plus 12 equals 36, which means that for this one, B equals 12, as does C, as does A. Okay, you see how we got that?
Yeah.
Okay, great. So, yes, come in, please. All right, so actually what happens is if you plug in either of these, they both work. So you can put either of these as the answer for this problem. And then did it also ask you to find the common ratio and the common difference?
It just said find the three numbers given that they add up to 60. 36.
Okay, perfect. So then here you go. Your three numbers in this case are all 12. And then in this case, they're negative 24, positive 48, and positive 12. Good?
Yeah.
All right. For those of you who are just now entering, we are currently on problem 12. After I finished all the problems for the first half of the unit review, I'll go back, answer any questions y'all have about anything, even if it's not in the unit review, even if it's just for one of the homeworks. I'm happy to answer questions about any of that. But for now, let's just get through the unit review, and then we'll see after that. All right, the next question is prove the following identities. I know a lot of people had some trouble with this one, so we'll really work through this if it loads any day soon. Did it not? Wait, let's try again. I'm sorry, sometimes it takes a minute to load. Okay, perfect. So we want to prove the following identities. If I can move over just a bit. Perfect. Okay. Okay. So if we're doing a proof, what I like to do is say what I'm required to prove, which shorthand for that is just RTP. So RTP stands for required to prove. In this case, for 5A, you are required to prove that n plus 1 choose 2 plus 1 choose 2 is identical to, remember the three lines means identical to, n choose 2 plus n. All right, so the first thing I want to do is I want to like fully expand my left-hand side. Shorthand for left-hand side is LHS. What you want to do in a lot of proofs, not all proofs, but a lot of proofs, what they want you to do is say that your left-hand side equals this, and then you want to try and push it so that your left-hand side and your right-hand side look the exact same. So here, n plus 1 choose 2. Another way you can write that is just n plus 1 choose 2, because that's the other form, n and r. You don't necessarily have to write it like that if you don't want to. I kind of like to write it like that just because it's easier to write in like bigger equations so I can fully see what's happening. So this is n plus 1 factorial plus 1 factorial. Oh my gosh. Again, sorry, it's kind of hard to write with a mouse. I'm trying. Factorial over 2 factorial, which is just 2, times n minus 2 factorial, or n plus 1 minus 2, which should be n minus 1 factorial. Okay, sorry. N minus 1 factorial, correct? Everyone good so far? Or do we have to go back a bit? All right, I'm taking that as a yes. Okay, so now what else can we write n plus 1 factorial as? Well, remember what we established before in one of our earlier classes is something factorial you can say is n, like for example, n factorial is n factorial times n minus 1 factorial. Or you can also write it as n factorial times n minus 1 or you can write it as n times n minus 1 times n minus 2 factorial. So you can just keep going and then this times this times this times this factorial. So it's always going to be a times a minus 1 times a minus 2 dot 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 a minus n factorial. Good? So what I want to rewrite this as is actually n plus 1 times n times n minus 1 factorial. And then by doing this, what I can do is I can cancel out the n minus 1 factorial in both the numerator and the denominator, right? So what I'm left with is n into n plus 1. Oh my God. 1 over 2. Everyone see how I got that? Or do we have to go back a couple steps and then rework it? All right, everyone good? Great. Okay. And then what I'm going to do is I'm going to write right-hand side, which I can shorthand as RHS, equals n choose 2. What was it? N choose 2 plus n. Okay. So it's n choose, oh my God. I don't want to write it like that. Sorry. What I like to do, like we showed over here, is just n choose 2 plus n. So that's going to equal n factorial. Admit n factorial over 2 times n minus 1 n minus 2 factorial. Sorry, not n minus 1 plus n. And then what I'm going to do, remember what we did here where we said the n times n minus 1, well, in this case, n is n plus 1. So n plus 1 times n plus 1 minus 1 times n plus 1 minus 2 factorial. We're going to do the same thing over here where we're going to go n times n minus 1 times n minus 2 factorial, so that we can do the same thing we did on the top where we can cancel out both stuff on both the numerator and the denominator. So we have 2 times n minus 2 factorial plus n over here. So n minus 2 factorial is going to cancel out on both the numerator and the denominator. So what you're left with is what you're left with is n into n minus 1 plus n. So you can just write n into n minus 1. And then I'm just going to put the n on the top plus n. I'm doing something wrong, aren't I? Oh, yeah, sorry. So because you're adding, you have to have a common denominator. So our common denominator over here is going to be 2. So if you have x, you're going to have n times n minus 1 over 2 plus what times n over 2, but because you have 2 as the denominator, you have to increase n, like what's on your numerator, by the ratio of whatever's on the denominator. So instead of having n over 2, you're gonna have 2n. Does anyone feel confused by that? If you do, we can go back and work through it. Sorry, I know that explanation was a bit rough, but anyone need help, or are we good to move on? Okay, we'll take that as a go sign. So what we can do here is actually rewrite this as n squared minus n plus 2n. Everyone, because we can distribute the n. We'll go down here. So you have n squared minus n plus 2n, which we're gonna add up in just a second. And then that's gonna equal n squared plus n. Plus n over 2. And then what we can rewrite this as is actually, see here, if we have n times n plus 1, n times n plus 1 is the same thing as n squared plus n, because you can factor out an n, and what you're left with is n plus 1. And then we have all of that over 2. And then because we've just shown that this, the left-hand side equals well, actually, what I normally do is I write out the left-hand side and the right-hand side. So you have n times n plus 1 over 2 equals n times n plus 1 over 2. Usually in proofs, you want to make it so that it looks exactly identical. So even if this said n plus 1 times n, I would just want to rewrite it as n times n plus 1. So you can further emphasize the fact that they're completely identical. And because of this, therefore, your left-hand side and your right-hand side are equal, or all identical in this case. So we're going to add an extra line. As you were required to prove, therefore, you have successfully proved the question. Does everyone get this? Do we have to go back and look over something? Or are we good?
I don't understand how we got like the factorials for both left hand and right hand side.
Do you mean factorials where we go here, n plus 1 times n minus 1 factorial?
Before that,
Over here?
like, yeah, how we're establishing the factorials.
Okay, so what actually happens is n choose r, which also equals n choose r. For every single thing, your n is always going to be whatever number is on the top, and your r is going to be whatever number is on the bottom. Do we understand that much at least? Yes?
Yeah.
So n choose r, the equation for it, if you want to memorize the equation, is just n factorial over r factorial into n minus r factorial, which is where we got n factorial over here. N is n plus 1. So we have n plus 1 factorial over 2 factorial. 2 factorial is just 2 times 1, which is just 2, times n plus 1 minus 2, right? Because we have n minus r. Your n is n plus 1. Your r is 2. So n plus 1 minus 2 is just n minus 1 factorial. And then we just we rewrote it so that we could cancel out things from both the numerator and the denominators to make life easier for us.
Okay, yeah, that makes sense.
Do you understand
Thank
it? Or
Yeah.
Okay, we're good? Anyone else have any questions for this one, or else we'll move on to B? All right. Guess we're good to go. Sweet. Here's to hoping it's actually recording instead of me thinking it's recording. Okay, so B over here is n, prove that n choose 2. Again, what I generally want to start out with is required to prove, because this shows explicitly exactly what we want to prove. What we're required to prove here is n choose 2 times n choose 2, or n minus 2 choose k minus 2 is identical to n choose k times k choose 2. Good? Again, sorry about the handwriting. It's kind of meh, but as long as you guys can understand, that's what I care about. So again, like we did in the problem right before, I'm gonna fully write out and expand my left-hand side. So the left-hand side in this, oh, okay. Sorry, my parents are watching an Indeed movie. So your left-hand side over here is n choose 2. If we really wanted to, we could rewrite this as n choose 2, which is the other form that I showed earlier. N choose 2 times n minus 2 choose k minus 2. Good? This equals, okay, so remember the thing that we just went over, n factorial over r factorial, r over here is 2, which is just going to be 2. R factorial times n minus r factorial, so you have n minus 2 factorial times n factorial on this one is n minus 2. So you're going to have n minus 2 factorial over here, your r is k minus 2. So you're going to have r factorial over here, which is k minus 2 factorial, times n minus r factorial. So we're going to have n minus 2 minus, in parentheses, I'm going to write this up here. Okay, so we're going to have n minus 2 minus k minus 2. Now this parentheses is really important to write, especially if you have a hard time visualizing things, because of the fact that the negative over here is going to distribute. I know I struggle with that a lot. I tend to forget to put the parentheses, so I don't distribute the negative, and because of that, my answer ends up wrong. But we're actually supposed to distribute the negative, so you have n minus 2 minus k plus 2. Your plus 2 and minus 2 are going to cancel, and you're just left with n minus k. So over here, that means your n minus r factorial is n minus k factorial. And then Jake, right now we're just going through all the problems. We're currently on problem 5. We've worked through 1 through 4. If you need any help, once we're done with the first half of the chapter review, I'm happy to go back and answer any homework related questions or any questions on this review itself. But for now, we're just going to stick with the review. Good.
But for the review, we only do have to do the ones on the paper, right?
Yeah, we only have to do the ones in the paper.
I was about to like actually jump off a bridge.
No, you only have to do the ones on the paper. Anything extra is just for your own enrichment. It's nothing that you have to turn in. And again, homework's not mandatory. So, oh, I don't care about that. Homework's not mandatory, so really, if you do homework, all it's doing is helping you and adding a little bit of like wiggle room in your grade in case something happens on a quiz or a test. Okay, so does everyone know that we can cancel stuff out when we're multiplying, right? Everyone knows this, where we don't have to re-explain algebra concepts. If we do, I'm happy to explain it, but if we don't, I'd rather move on. Also, ignore the extra noise. That's, again, my parents are watching an Indian movie. Okay, so we can cancel out the n minus 2 factorial and n minus 2 factorial from both the numerator and the denominator. So in the numerator, we're just left with n factorial over 2 times k minus 2 factorial times n minus k factorial. Okay? Now, I'm going to leave it like this just because I don't know if I want to expand it more or expand it less or like do something else to it until I can figure out what my right-hand side equals. And then we can figure out what we have to change in either of the equations, or if we don't have to change anything, perfect. We've just proven whatever it is we have to prove. So over here, your right-hand side equals, again, we're going to rewrite it in this formula just so it's easier for us to see. You have n choose k times k choose 2. Okay, so again, use the formula. N factorial in this case is quite literally n factorial over k r factorial, which over here is k. So you're gonna have k factorial times n minus r factorial. Over here, n is n, r is k, so you have n minus k factorial times, again, k factorial over here, which is your n, over your r factorial here is just 2. 2 factorial, again, is just 2. So we write 2 times n minus r factorial. N minus r is k minus 2 in this case. So you have k minus 2 factorial. Now, again, we can cancel out both the k factorial, both k factorials from the numerator and the denominator. So what we're left with in the numerator is n factorial over n times n minus k factorial times 2 times k minus 2 factorial. Everyone see how we got that, or do we want to go back and rework through some of it? We're good? All right, we're going to take that as a yes. So notice here how your numerator is the same, and your denominator is actually the same. It's just in a different order. So remember what we said before, where we want to make sure that your left-hand side and your right-hand side look the exact same, just so we can further emphasize the fact that they're completely identical. Over here, I'm just going to write my left-hand side, which is n factorial over 2 times k minus 2 factorial. Sorry, there we go. Times n minus k factorial is equivalent, or really, if you want, you can go straight to identical, but we haven't completely shown that they're identical yet. So we're not going to write identical. And then n factorial again. And then what we're going to do, we're going to rearrange the denominator to look exactly like this. So we have the 2 over here. We have the k minus 2 factorial. And then we have the n minus k factorial. If you message me in the chat, give me 1 sec. I don't know who you are, so sorry. So as we can see, your left-hand side equals your right-hand side. Therefore, we can state that your left-hand side, your LHS, is completely identical to your right-hand side, your RHS, as you were required to prove. So as RTP, which again stands for required to prove. All right. Anyone have any questions on what we just did? The test is kind of going to be similar, kind of not. It's kind of just going to be like an IB test paper, but again, my brother's going to be really lenient with everyone because obviously we're in 10th grade, we haven't really done IB yet. Just know the concepts and what you're doing, you'll be completely fine. Again, your chapter review is kind of just to make sure you really understand the concepts and make sure your mind is thinking. A lot of the stuff on the chapter review is much harder than what's going to be on the test itself. So your chapter review is just to make sure your mind is working and you actually understand the concepts and what's going on. All right, last call. Anyone have any questions for 5B? If not, we're going to move on to the next question. Anyone? No. Okay, we're going to take that as a no. Delete. Where's delete? Okay. Now we're going to move on to number 6. Okay. And then we'll do 13 and then 14, and then we can go answer any other questions. If you need 15 onwards, you can go ahead and move to room 2 and work with Samir. Those are the ones he's working on.
Just FYI, Samir just finished 15, so we'd have to
Oh.
wait for the recording.
Is 15 is 15 the really long one that everyone's struggling with?
Yeah, it took like
Okay.
45 minutes.
Oh, damn. Okay. Okay, it's fine. It's fine. If anyone needs help, again, once we're done, Samir and I, either one of us are more than happy to help out with any questions, problems you guys have. Again, not just on the review, even on the homework. If you don't understand something, feel free to ask. We'll work through it step by step. Okay. Show that n choose 0 plus 3 times n choose 1 plus 3 squared times n choose 2 plus ... plus 3 to the power of r times n choose r plus ... plus 3 to the power of n times n choose n is equivalent to 2 to the power of 2n. So actually over here, they were really nice for us. They gave us the general term right here. Everyone knows what the general term is, yes? If not, speak now or forever hold your peace.
I'm speaking now and I'm not holding my peace.
You don't know what the general term is?
Can you just give me the equation for it?
Okay,
me
so the
line.
general term, there's actually not a set equation for it. For arithmetic equations, your general term is going to be u sub 1 plus your difference times n minus 1. That's going to be your general term for an arithmetic equation or arithmetic sequence, not equation, and series. For a geometric sequence and series, your general term is going to be u sub 1 times r to the power of n minus 1. So over here, this is your general term for the binomial expansion.
Never mind, I knew that. Sorry, I thought that was completely different. Thank you.
Yeah. Over here, this is your general term. We're just gonna write it as gen term. This is your general term for your binomial expansion, right? So we have as our general term n choose r times 3 to the power of r, right? So again, for those of you who don't know what binomial expansion is or don't quite remember, it's n choose r. R in this case is whichever term the equation is, and then n in this case is whichever power the term is being, whichever power your equation is to the power of. So if you have like 1 plus n to the power of 5, your n is going to be 5, and then depending on whichever term of the sequence you're working on, the r is going to change based on that. Good. All right. Sorry, give me a sec. Okay, so what we have here, your equation for this is actually going to be n choose r times, okay, if we have a plus b to the power of n, this is what we're going to work with. So the equation for that is just going to be n choose r times a to the power of n minus r times b to the power of r, okay? So b in this case we can see is 3 because 3 is simply raised to the power of r, which means that because there's nothing else in your general term, whatever your this term is has to be equal to 1. And what else is equal to 1 other than 1 to the power of anything, or something to the power of 0? In any case, it's never going to be to the power of 0 because regardless of, unless you're in the general term, it would show you if you had anything else. So it's not going to be to the power of 0, which means that a in this case is just 1, and then b in this case is c. So we can rewrite this as 1 plus c, not c, sorry, 3. Again, sorry, it's been a long day. We'll work through it. But we have 1 plus 3 to the power of n, which is also equal to 2, or not 2, 4 to the power of n. Sorry, that says 2. I don't know why that says 2. That equals 4 to the power of n. 4 can be rewritten as 2 to the power of 2, and then that whole thing to the power of n. And again, if you have one exponent taken to the power of another exponent, you just have to multiply the two exponents. So in this case, you get 2 to the power of 2n. Therefore, your left-hand side equals your right-hand side as required, or I'm just gonna like right here, 2 to the power of n as required. Rec. That's what we're gonna write. Anyone have any questions? Feel free to ask about anything. We'll go through it.
Can you go over that last part really quickly again?
Last part being the 1 plus 3 to the power of n.
Yeah. Do you just like write it as in like general terms?
Okay. So remember binomial expansion is a plus b to the power of n?
Yeah.
Okay. So we said that b to the power of r is, in this case, they clearly give you something to the power of r. In this case, that something is going to be b, and b in this case is 3. So we can put in 3 over here. And because there's nothing else in your general term, that means that they would give you if there's another number, but that means that the other number is just going to be 1. So you have 1 plus 3 to the power of n, right? Because we substituted in 1 for a, which over here we can see just gives you 1. And then plus 3 to the power of n. So 1 plus 3 is 4 to the power of n. 4 can be rewritten as 2 to the power of 2 to the power of n, right? Because 4 is 2 to the power of 2, and then you have the whole thing to the power of n. And if you have one exponent to the power of another exponent, you can multiply the two exponents. So you have 2 to the power of 2 times n, which is 2n. So that equals 2 to the power of 2n as you're required to show. So you got the answer. If you don't understand it, feel free to ask again. I'll find a different way to explain it, maybe. All right, everyone good?
That was way easier than I thought it was.
Yeah, just take it step by step.
Wait, I could have done that.
Yeah,
Okay.
something that really helped when I asked my brother was he grouped these terms together, which really helped me see it. And then if you get to the general term, you can see that it's 3 to the power of something times n choose r, which is basically what's exactly over here. That really helped me see what the problem said. So if that helps you, you know. Fun.
Wait, so you're saying 3 equals b, like going
Yes.
back to the binomial expansion,
Yeah.
and then the a to the power of n minus r is 1.
Yes, because 1 to the power of anything is just going to equal 1, which is why they didn't write anything in your general term.
Oh, okay.
Good. Another thing you could think of it, another way you could think of it is what to the power of n minus r is going to equal 1. It's always going to be 1. So yeah. Any other questions, or should we move on to the next one? We're all good? Okay. We're good? Okay. Perfect. Delete. Delete. Okay. We are gonna do 13 and then we'll move on to 14. Bear with me on 13 and 14 because there are quite a few parts to the problem. So writing out the problem is gonna take some time, especially with the mouse. Any day. Want to work. Thank you. All right, we're gonna take it bit by bit. Oh, sorry, one thing I didn't mention, if you need to take screenshots of something, feel free to take screenshots. Yes, this recording will be posted in the server, and me and Samir were thinking of also posting it on a channel on YouTube called Revids Now, which was founded by the former seniors. So a lot of grades are like kind of just post reviews right before we have like a big test, or if people need to review something, we'll just as a grade, we'll just decide to have a review session with everyone. So this might be posted on that channel, and if not, it's always going to be posted on the Discord. So yeah. Okay, and how many ways can the letters of you good? Jake,
What?
are you okay? Some noise just came out. I don't know if
It was my cat.
oh, okay. Poor cat. Anyways, in how many ways can the letters of the word harmonics be arranged? How many letters are in the word harmonics? You have HARMONICS. So that's nine letters. So all you're gonna have is 9 factorial because of the fact that order doesn't matter. If order did matter, then that would be a different situation. Thankfully, order does not matter. But over here, you just have 9 factorial, which equals, correct me if I'm wrong, but it should be 362,880. Is that what we all got? Yes, no, maybe so. Jake, you good?
I said, yeah. Now, do you have to on the test like put in a calculator 9 factorial and figure out it makes the numbers, or
I mean, if you wanted to fully expand 9 factorial by hand, feel free to, but
I just didn't know if we like literally had to answer with
oh,
the expanded
yeah, no,
form.
okay, my brother would like to inform me that its order in this case actually does matter, because if order didn't matter, you would be getting the same answer every single time. So yes, he would like to inform us that order does matter. Also, another thing he said is that if you have like a big number, and it's a factorial, it's a no calculator problem. Again, sorry, I don't know if I mentioned this on the test. There will be calculator problems and no calculator problems. But if it's a no calculator problem, you can just leave it as is. So 9 factorial, you can just write as 9 factorial, or if you have a calculator, go ahead and expand that out. Everyone get that, or do we have to go back and visit some of it? All right, no answer. I'm going to take that as a no.
We're good on this.
Huh? Okay. Okay, got it. Okay, B, hopefully we have enough room. Determine how many numbers bigger than 30,000, less than 9,999,999, and divisible by 5 can be formed using the digits 0, 1, 2, 0, 1, 2, 3, 5, 8, and 9. Okay, so what I'm gonna do is I'm gonna show out like in seeds. So I'm gonna do 990,000,000, 2, 3, 4, 5, 6, 7. So we have 7 seeds over here. 1, 2, 3, 4, 5, 6, 7. Okay. You have this in between. Okay. Here's how I'm thinking of it is between 9,999,999 and 30,000, you can have numbers that are 5 digits long, because 30,000, if you have 30,010, that's 5 digits long. You can have numbers that are 6 digits long, right? Because 6 digits is in between 7 digits and 5 digits. Or you can have a number that is 7 digits long, because 9,999,999 is 7 digits long, right? So you can have a number that's 7 digits long. You can have a number that is 6 digits long. So 1, 2, 3, 4, 5, 6. Or you can have a number that is 5 digits long. So 1, 2, 3, 4, 5. Does someone have a question? I heard a mic unmute.
Can you explain why it could be 7, 6, and 5 again?
Can you say that a bit louder? I can't really hear.
Can you explain why it could be 7 number 6 numbers 5 is?
Oh, yeah, of course.
We're limited by 30,000 and then the 9
Yeah, you're
million.
limited by exactly, Jake. You're limited by 30,000 and you're limited by the number 9,999,999. So your limits are those two numbers. Any number in between those two numbers can be a number that's between them and divisible by 5 formed using the numbers that they give us. Right? If we have a 4-digit number, that's less than 30,000, so we can't have a 4-digit number. If we have an 8-digit number, that's more than 9,999,999, so we can't have an 8-digit number. However, we can have a 7-digit number, because think about it. If you have even 9,999,995, that's in between 30,000 and the last number, and it's divisible by 5, therefore it would be part of the set that can be formed by this. If you have 30,005, that's divisible by 5. It can be formed using the numbers that they give us, and it's in between 30,000 and 9,999,999. Therefore, that can be part of the solution set. And because you can have 7 numbers and 5, because you can have 7-digit numbers and 5-digit numbers, and everything in between that's divisible by 5 can be part of the solution set, you have to have 6-digit numbers as well. Do you understand? Or do we have to explain it a different way? If you need it. Good? Okay. So something you always have to remember is that you cannot have 0 as the first number. You can have any number except for 0 as the first number. So over here we have 1, 2, 3, 4, 5, 6, 7 numbers that you can use. Of those, one of those numbers you cannot use in the first seed. So here here we only have 6 options, right? Okay, sorry. Here you have 6 options. For your second seed, you have all 7 options, correct? Again, stop me anytime if you don't understand what's going on. I'm perfectly happy to go back a couple of steps and then we can figure out how we can best solve the problem so that everyone understands. You can also have 7 digits that you also have 7 options in the third seat. You have 7 options in the fourth seat. You have 7 options in the fifth seat, 7 options in the sixth seat, but you only have 2 options in the last seat because of the fact that the number has to be divisible by 5. Anything that's divisible by 5 has to have a last number of either 5 or 0. Therefore, you only have 2 options in this last seat. Everyone understand that?
I completely don't understand what just happened.
Do you want me to start from the beginning, or is there like
Yeah.
just
I don't understand how we got 6 and then 7 for the rest and 2.
Okay, so if you have a number in this kind of sequence or in this kind of a problem, you can't have 0 as the first number of your you can't have 0 as the first digit of your number, okay? So because there are 7 total numbers, but 0 is one of those numbers, 0 is not an option for your first seat. You only have 6 options for your first seat, which is why it's 6 in the first one. Times it's 7 over here, because now you can add 0 back in to all the options you have. And it doesn't say that the numbers aren't allowed to repeat or anything like that, which is why we don't have any restrictions on like you go from 6 to 5 to 4 to 3 to 2 to 1. You don't have to do anything like that because of the fact that it doesn't say anything about using repeated numbers or anything. Jake, did you have a question?
No,
Oh, okay, sorry, you kept unmuting. So, okay.
my
Emma,
cat's
do
on
you-
my keyboard. Sorry
Oh.
about that.
Oh, don't worry about it. Hema, do you understand now, or do you want me to explain it a different way?
Yes, I didn't realize we were looking at the digits. That's
Okay.
Yeah.
So you understood. We're good?
Yeah, we're good.
Okay. Now, same thing over here. For the first seat, we can't use the number 0, so we're limited to 6 options. Where we have 7 options over here on the second seat. We have 7 options on the third seat. We have 7 options in the fourth seat, 7 options in the fifth seat. And then again, we only have 2 options in the last seat because again, the number has to be divisible by 5. Therefore, you can only use 5 or 0 in the last seat. We're good with that? All right, we're gonna take that as a yes. And then last one, same thing. First, okay. So the last one is actually a special case because of the fact that the number has to be greater than 30,000. So your first number can't be 1, it can't be 2, and it cannot be 0. Does everyone understand why that is?
Yep.
Good? Yeah, sorry, Jake, I got that. Okay, that means you're only limited to 4 options for your first seat because of the fact that you have a limit on like the end or what the last number can be. And then once again, you have 7 options for your second seat. You have 7 options for your third seat. You have 7 options for your fourth seat. And lastly, once more, you have 2 options for the last seat because, again, divisible by 5 can only be end in 5 or 0. Oh, yeah. Sorry, give me 1 second. My brother would like to apologize for interrupting. He's going off to college, so he's asking if he can steal something from my room. Okay, everyone understand where we are so far? Everyone have any questions, concerns, whatever? All right, I'm gonna assume that means that we are good to go. So 6 times 7 times 7 times 7 times 7 times 7 times 2. Anyone correct me if I'm wrong, but if you plug that into a calculator, that is 201,684. 1,684. 6 times 7 times 7 times 7 times 7 times 2. Anyone, again, correct me if I'm wrong, but plug that into a calculator, you get 28,812. 8, 1, 2. And again, last one, 4 times 7 times 7 times 7 times 2. Correct me if I'm wrong, but that should be 2,744. Okay, now something you have to keep in mind for this kind of a scenario is that you have to subtract 1 from the total number of numbers you can have because of the fact that the last number, the 4 times 7 times 7 times 7 times 2, that includes the number 30,000, and it has to be bigger than 30,000. It doesn't say anywhere that it has to be greater than or equal to 30,000, right? And because the 4 options over here include 3, and the 2 options over here include 0, you can end up getting 30,000 from here, which means you have to subtract 1 total scenario out of every scenario that you can possibly have. Does everyone understand why? Speak now or forever hold your peace. Okay.
Can
Hannah?
you repeat that? I'm sorry.
No, you're fine. Don't worry about it. Okay. So something like this. In the last one, we have 4 options. Of those 4 options, 3 is included. Of these 7 options, 0 is included. Again, 0 is included here, 0 is included here. And because it has to be divisible by 5, 0 is also included here. However, this number is equivalent to 30,000. And over here, they tell us that it has to be bigger than 30,000, but they never state that it can be equal to 30,000. So of every single option or scenario that's possible, we have to subtract 1 option because 30,000 can't be part of the solution set. Do you understand, or do we want to go through it a different way?
No, I got it. Thanks.
All right, great. So again, anyone correct me if I'm wrong, but if you plug that into a calculator, you should get 233,239. We good?
Did you add them with the?
Yeah, you add this, you add every single possible, oh my God, go back. You add every single possible scenario here, plus every single possible scenario here, plus every single possible scenario here, and then subtract 1 from everything. Because again, like we stated before, blah, 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 blah. And then that should be your answer. And if not, please correct me now. Okay, yeah.
Subtract 1 again.
Say that one more time. You're kind of quiet.
Why do you subtract 1 again?
You subtract 1 because of these 4 options over here, you have 7 digits as your options, correct? Of these 4 options, 3 is included. Of these 7 options, 0 is included. Of these 7 options, 0 is included. Of these 7 options, 0 is included. And of these options, because it's divisible by 5, 0 is also included. However, it says that determine how many numbers bigger than 30,000, but it never states bigger than or equivalent to, or like greater than or equal to, right? Which means that 30,000 cannot be part of the solution set that you get. So out of every single scenario that you can have, you have to subtract 1 scenario to account for the 30,000 that you're going to end up getting. Do we get that, or do we want to talk about it differently?
I get that.
All right, great. Anyone have any more questions over 13B? If not, we'll move on to 13C. We're good? All right, I'm gonna take this and delete it and then what we're gonna do, we're just gonna move this up in case anybody still needs it. You have it right there to look at. I'll just move that up a bit so I have more room for 3. Okay. Now, the last question is asking what? In how many ways can a committee of 5 people be selected from 7 men and 5 women so that there are at least 1 male and 1 female, and there are more women than men on the committee? Sorry, that cut out, but I should say men than women on the committee. So, a committee of 5 people. We're gonna go back to the chairs just because I personally find that easier to see. If you think that memorizing the equation will help you, feel free to, but I don't really think that memorizing the equation will help you fully understand the concept, which is why I like to do it in the chairs, especially if it's stuff like this where I just need to visualize it. So we have a committee of 5 people, which means that there are 5 chairs. 1, 2, 3, 4, 5. Okay? So what I like to do first is write out all of the information I'm given, right? So I have 7 men. I'm gonna abbreviate that as 7M. I have 5 women. I'm gonna abbreviate that as, hello. Thank you. I'm going to abbreviate that as 5W. And then total, I have what? 7, 8, 9, 10, 11. Or actually, I don't care about the total number of people. So now what I'm going to do is I'm just going to draw a little chart. I have, remember, a key thing in this is that there's at least one male and one female, but there are more women than men on the committee. So out of 5 chairs, if there's going to be more women than men on the committee, that means that either 3 of those chairs are women or 4 of those chairs are women. Correct? Everyone understand that? Or do we want to go back? Okay. So that means we have 2 cases. Case 1 and then case 2. Okay. So in case 1, we can have that's male, and then that's men, and then women. So in case 1, we have 1 male, and then the rest of the seats are going to be filled up by female, because that makes sure that all of the requirements are met. So there's at least 1 male over here, and at least 1 female. 4 females is more than 1. And there are more women than men. 4 is greater than 1. Therefore, that meets all the requirements. And then in case 2, there are 2 males. Again, at least 1 male fulfills the requirement. And then 3 females, again, at least 1 female, more women than men. 3 is greater than 2, and 3 is also greater than 1. Therefore, it fulfills both requirements. So that means for case 1, out of 7 men, we choose 1 man. And then times, out of 5 women, we choose 4 women. So it's 5 choose 4. And then we add all of those solutions to the solutions of case 2, which is out of 7 men, we choose 2 men, times out of 5 women, we choose 3 women. Does everyone understand this, or do we want to go back? Okay. I'm going to assume that you all understand it. Again, if you don't understand something, please do speak up, because I can't help you if I don't know the fact that you're struggling about something. Okay, so 7 choose 1. Does everyone know factorials? Again, we did this in just a couple problems earlier. I guess I could write this out if it would like to work. Maybe do you know? Okay, so you have 7 factorial over 1, which 1 factorial is just 1, times 7 minus 1 factorial, which is just 6, correct? 6 factorial, times 5 factorial over 4 factorial times 5 minus 4 factorial, which is just 1. Again, we don't have to write anything for that. Plus, we have 7 factorial over 2 factorial times 7 minus 2 factorial, which is 7, so it's 5 factorial, times we have 5 factorial over 3 factorial times 5 minus 3 is 2, which is just 2. 2 factorial is 2 times 1 again, so you just get 2. Shut up. Ignore my brother. He is not important, regardless of the fact that he's your teacher. Anyways, 7 factorial over 6 factorial. Again, we have 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 times 5 times 4 times 3 times 2 times 1. We can cancel out 6 factorial onwards from both the numerator and the denominator. So what we're left with is 7 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. We can cancel out 4 factorial from both the numerator and the denominator. So we're left with 5, which equals 35. We'll write that in the next step. And then again, 7 factorial over 5 factorial times 2. We can rewrite this as 7 times 6. Because does everyone remember the rule where n factorial is also equal to n minus 1? Where n factorial is equivalent to n factorial times, oh my god, geez. where n factorial is equivalent to n times n minus 1 factorial, which is also equivalent to n times n minus 1 times n minus 2 factorial, which is also equivalent to n times n minus 1 times n minus 2 times n minus 3 factorial, dot, 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 so on and so forth. Does everybody remember that rule? Yes, okay. So we have 7 times 6 times 5 factorial. Oh my god. 5 factorial. And then we can cancel out both the 5 factorial from the numerator and the denominator. And then 6 times 2 is 3. So we can rewrite that as 3. 7 times 3 is just 21. We have 21 times, again, we have 5 times 4 times 3 times 2. And then we don't really have to write the 1 just because it's implied. And then 3 times 2. And then again, times 2 over here. We can cancel out the 3 times 2 from both the numerator and the denominator, which is also just 3 factorial. And then 2 goes into 4 2 times, so we have 5 times 2, which is 10. So our final answer is going to be 35 plus 210, which equals 110, which equals 245. So your answer for this should be there are 245 ways in which a committee of 5 people can be selected from 7 men and 5 women, so that there is at least 1 male and 1 female, and there are more women than men in the committee. Is everyone good, or do we want to go back? Does everyone understand what's going on?
Probably super good.
Okay. Anyone else help, or can we go ahead and move on to the next problem? Okay.
I gotta go. I've done everything done. Thank you
Of
so much.
course.
Feel less stupid now.
You're not stupid, Jake.
That's the big one. Y'all have a good one.
Shut up. You're not stupid. Okay. And lastly, we are going to solve 14, and then we can go back and solve any homework problems or any other review problems that you guys need help with. Okay, let's let A equal, you know what, you guys already see that there. I'm not going to rewrite that. What have I been writing this entire time? Sorry. We're going to increase the font size by like 1. Okay. Yeah, that feels better. Okay, so A, write a squared minus b squared in terms of x and y, and hence show that a squared minus b squared equals a minus b times a plus b. Okay, so a squared minus b squared, right? Minus b squared. We're rewriting this in terms of x and y. A is x plus y, so we have x plus y whole squared. Again, bear with me, this is annoying to write with a mouse. But x plus y whole squared minus x minus y whole squared. Everyone understand why I did this? Why or what's going on? Everyone understand? Yes? Okay. So what we're gonna do is we're gonna expand both terms, right? Everyone knows how to expand a plus b whole squared. It's gonna be a squared plus twice ab plus b squared, which in this case is x squared plus 2xy plus y squared. Sorry if that looks like a multiplication sign. And then that minus x squared minus 2xy plus y squared. Good. Are we all following so far, or do we need to go back a couple steps and then retrace our route? We good? Okay. So what we're gonna do now is just combine like terms, cancel out whatever we can. So x squared minus x squared is 0. We don't have to write anything for that. 2xy plus, because minus and minus make plus, remember that. You have to distribute the negative sign. 2xy plus 2xy equals 4xy. And then y squared minus y squared is nothing, so we don't have to write anything for that. Which means that this equals 2xy. Which means that, okay, So, sorry. Again, remember how earlier I was saying required to prove? I like to write that out. What I would normally write here is what we're required to prove is a squared minus b squared equals a minus b times a plus b. And then I would consider a squared minus b squared to be the left-hand side. So what I'm doing here is saying, or we can just do this, LHS equals, again, LHS is shorthand for left-hand side. Your left-hand side equals a squared minus b squared, which equals x plus y squared minus x minus y squared, okay? Which means that your left-hand side is 4xy. Now your right-hand side is a minus b into a plus b. Now, if we rewrite this in terms of x and y, what we get is x plus y minus x minus y. Your x's are going to cancel, and you're going to have plus, well, you're going to have 2y. Everyone see how we got that, or do we need to go back and then? We good? Okay. And then x minus, or x plus y plus x minus y. So we have 2x plus y and minus y cancel. So we're just left with 2x. And this equals 4xy, right? Because 2y times 2x, we all know how to multiply numbers. Yes. Okay. Therefore, your left-hand side equals, that is not an L, because I am an L. Anyways, your left-hand side equals your right-hand side as, therefore, left-hand side equals right-hand side as you're required to prove. Okay, does everyone understand how we got that, or do we need to go back and figure it out? Or what I would actually probably write for this is left-hand side equals right-hand side. Therefore, because it says hence show that this is this, so I'd probably write left-hand side equals right-hand side. Therefore, a squared minus b squared equals a minus b into a plus b. Okay, does everyone understand how I got there, or do we need to go back?
Can you just go over all of it, like a brief look?
Okay, well, yeah, we'll just talk over it. So we want to prove that a squared minus b squared equals a minus b into a plus b, correct? So your left-hand side in this equation is a squared minus b squared, which is why I wrote LHS equals a squared minus b squared. We want to write it in terms of x and y, and they give us here a equals x plus y and b equals x minus y. So a squared will become x plus y whole squared, minus b squared will become x minus y whole squared. We expand the terms, so you get x squared plus, again, binomial theorem, a squared plus 2ab plus b squared for power of 2. So you get x squared plus 2xy plus y squared minus x squared minus 2xy because it's x minus y plus y squared. If you distribute the negative to all your terms, you have x squared minus x squared, that cancels out because that equals 0. You have 2xy plus 2xy, which equals 4xy. Then you have positive y squared minus y squared, which cancels out because that equals 0. And then we want to show that that equals whatever's on the right-hand side. Your right-hand side over here is a minus b into a plus b, which if you write in terms of x and y, you get x plus y minus x minus y. Again, you're going to have x minus y in parentheses. Sorry, I'll write this out really quickly just so it's easier to see. X plus y minus x minus y, right? The minus x and positive x cancel out. You're left with plus y, and then minus and minus make positive. So you have 2y over here. You can see I wrote 2y. And then a plus b is x plus b plus x minus y. So again, you have x plus y plus x minus y. Your x and x is going to form 2x, plus y and minus y will cancel. So you have 2x. 2y times 2x is equivalent to 4xy. as we can show, left-hand side equals right-hand side. Therefore, a squared minus b squared, which is your left-hand side, equals a minus b into a plus b, which is your right-hand side. Good?
Thank you.
Okay. I will erase this right now unless somebody needs to copy something down, in which case, please let me know so that you can copy it down. Are we all good? Oh my God, Jesus. Delete. Okay, use the binomial theorem to write a cubed and b cubed in terms of x and y. Can someone? All right, give me one sec. Oh. Okay. If you will give me 1 second. Oh, sorry. Okay. Samir said that he didn't do 14D and E. We're working on that right now. We don't have to worry about that. And 25, because he's not sure how to do C and D, we can work through 25, right? I did 25 today, I hope. Well, I think I did 25. So if anybody needs help on 25, we can work through that. Good? All right. Sorry, will you give me 1 second? I have to go to the bathroom. Again, anyone, if anyone needs to go to the bathroom or like take a quick snack break or anything, be free.
Ash, can you check Discord?
Okay. I've been writing notes of it, like so that I can turn it in as like the homework.
Yeah, no, I've literally been studying for like over like 3-4 hours. So can you like just send the screenshots?
Yeah, I'll just send you a photo of my notes. I mean, I only joined like whenever she was doing question number 6,
Oh,
so I don't even have all of it.
yeah, just screenshot the stuff that Kunda writes. All right, thanks.
Wait, did I even do number 6? Okay, yeah, I did, but I have no idea what I did.
All right, is everyone back? Everyone left, right? I think. All right. Is everyone back? Yes, no, maybe so.
Yeah.
Okay. Hamash, I'm gonna assume you're there.
Yeah.
Okay. Sorry. Again, if you need help with anything, just feel free to ask. Yes. Okay, I heard. Okay, I heard. Okay. So we are on 14B, correct? Right? Yes, no?
Yes.
Okay, good. Sorry, I'm very forgetful. Binomial theorem to write a. Wow, I just forgot how to write. Okay, use binomial theorem to write a cubed and b cubed in terms of x and y. A cubed equals what? A cubed is equivalent to x plus y whole cubed, which equals x cubed. Again, this is one of the easy ones just because you should kind of like just learn to know the first 5, 6 rows of Pascal's triangle. This is part of the first 5 or 6 rows of Pascal's triangle. So you can easily expand this to get x cubed plus 3xy plus, or sorry, that should say plus 3x squared y plus 3xy squared plus y cubed. Good? We all understand how we got there? Okay, great. And then b cubed, which is x minus y whole cubed, which equals x cubed minus 3x squared y plus 3xy squared plus y, or sorry, that should be minus y cubed. All right, we all understand how we thought. Sorry, what?
It's also minus 3xy squared, right?
No, okay, so if you have a minus, what happens is you go positive, minus, positive, minus, positive, minus, so on and so forth.
Oh.
So you're gonna have plus x cubed minus the second term plus the third term minus the fourth term.
Okay.
Good. All right. Anyone have, Ramesh, you got any questions?
Nah, I understood it.
Okay,
For
good.
once.
Great. Okay. Do you guys want me to delete this or should I just move it up? Because we're gonna use it in part C.
I don't care.
Okay, I'll just decrease the size and then keep it there for reference. Wow, that is not what I wanted. But we're just gonna move it up a bit and then keep it there for reference. And then can we crop this? No, we cannot. Can we? Oh, okay, yeah, no. Okay. Anyways, part C. Use your results in part B to show that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Sorry, my mouth is dry. Okay. So again, what I'm going to start out with is what I'm required to prove. In this case, I'm required to prove RTP. I'm required to prove that a cubed minus b cubed equals a, oh my god, minus b times a squared plus ab plus b squared. Okay, so we already solved for a cubed and we already solved for b cubed. So all we're going to do is substitute in whatever we solved for what's already there. So we have x cubed plus 3xy plus, or 3x squared y, sorry, plus 3xy squared plus y cubed, which is a cubed, again, like as we showed here. And then we subtract from that x, oh god, okay, x cubed minus 3x squared y plus 3xy squared minus y cubed. We all understand how we got there? Yes, no, maybe so. Maybe.
Yes.
Great. Okay. Again, we're just gonna combine like terms. X cubed will go away because minus x minus plus x cubed minus x cubed. 3x squared y plus 3x squared y because minus makes positive. We get 6x squared y. Squared y. Again, right now we're showing your left-hand side, which we should probably write because it makes life easier for us. But and then 3xy squared minus 3xy squared cancels, and then plus y cubed minus makes plus y cubed is plus 2y cubed. Okay, and then your right-hand side, okay, your right-hand side equals a minus b, which is, we showed what a minus b was in the earlier problem, right? Let me just look at that really quickly. A minus b is 2y, because remember we showed that in part A. So that's like kind of the beauty of these problems. You don't have to resolve everything for all the parts. Whatever they give you in an earlier part of the problem will likely be used in a later part of the problem, which just makes life easier for us. Okay, so again, a minus b, A minus B, we established earlier that that was 2y. Right? Yes.
Yes.
Okay. And then a squared plus ab plus b squared. That one you actually have to write out. A squared. Again, we put that in the earlier problem. It is what? X squared plus 2xy plus y squared. Plus, I'm just gonna put giant parentheses around that. Sorry, plus AB is x plus b, or x plus y times x minus y. Again, we established earlier that that was what? For xy, I believe. Was that what we established? X plus y times x minus y. Sorry. Notepad here. Okay, we're gonna steal his notepads. Okay, sorry. Just want to make sure that I'm actually doing this right and I'm not like spouting random nonsense that you guys aren't gonna get any help from. X plus y times x minus y is gonna be x squared. Oh, okay. X squared minus xy plus xy minus y squared. Minus x. Okay. Okay. So the AB is again x plus y times x minus y. If we expand that, we get x squared plus xy minus xy. Those will cancel, and then minus y squared. So we have plus x squared minus y squared, and then plus b squared. Again, we already established that earlier. B squared was x squared minus 2xy plus y squared. X squared minus 2xy plus y squared. Again, we can see that because they made us solve this, we already found what b squared was, which is nice for these kinds of problems so that you don't have to resolve everything. Now what we're just going to do is first we're going to combine like terms in this part. So we have x squared over here, x squared over here, and x squared over here. You should get 3x squared. Plus 2xy. No xy problems over here. And then minus 2xy, so those will cancel. Plus y squared minus y squared plus y squared. So those two will cancel, and then you're just left with plus y squared. You've already, and then we've already done all the x squared terms. So what you're left with is 2y into 3x squared plus y squared. Okay. And now we just expand this. So you get 6x squared y plus 2y cubed. Again, over here, writing left-hand side and right-hand side makes it easier for us because now all we have to do is state that left-hand side equals right-hand side as you were required to prove. So LHS equals RHS HS. Therefore, and 3 dots is therefore. Therefore, this equals this. I'm not gonna write this out right now just because, yeah, but yeah. Okay, we all understand that, or do we need to go back and work through some of it?
Is your brother gonna make us do this on the test?
I don't think I'm allowed to tell you because I technically don't know. Like, nobody knows the exact problems on the test except for my brother, but like he's kind of told everyone like a general idea of study this, know this. I don't know if we're gonna have anything quite as intensive as this, but
Yeah, that's like what I meant.
Yeah, I don't think we're gonna have anything quite as intensive as this, but it is good to know this stuff.
Okay.
Although don't take my word for it. There might be something quite as intensive as this that I just don't know about. So, you know, study, fun. Yes, delete, delete, delete. Okay, Samir said he didn't do 14D and E. So really quickly, I'm just gonna post on the Discord that if anyone didn't understand 14D and E, they should join. How many problems are there? Wait, we'll also go over 25, I think he said he couldn't cover. And do you guys want to go through 25 and 20?
Yeah, sure.
Okay, I'm fine going over whatever you guys need help with. Okay. Sorry, give me one sec. Okay. We can go ahead and do 14D right now. Okay. Use the binomial theorem to write a to the power 4 and b to the power 4 in terms of x and y, and use your result to factorize a to the 4th minus b to the 4th. So, okay. You know what, actually, you guys can take like a 5-minute break. I'll let whoever is gonna join if they need to join. And then
You should also like add Precal or something.
oh yeah, I should probably do that.
Yeah.
Do. That is my brother. That is not what I want. Ah, okay, here we go. Sorry, I never used to use Precal before they decided that we were gonna use it for the class, so I'm kind of useless when it comes to Discord. Okay, sorry, one quick question. After we start doing like the actual pre-calculus curriculum when Miss Alstrom and my brother switch, do you guys still want to do these kinds of reviews for whatever unit we're learning? Because if you do, I think I can work something out with.
I think that would be helpful.
Okay. Okay.
If Miss Alstrom goes as fast as your brother did, then yes.
Miss Alstrom, I don't think we'll go quite that fast, just because screenshots of. Okay. Ah. Okay. let's give everyone about like 1 or 2 more minutes, and then we can go ahead and do 14 D&E. And then we'll move to, I think I said I was gonna solve 20, right? Hannah, do you need help with 15? Because I know Samir went over 15, but you weren't able to join his since you were doing this one.
Yeah, I haven't gone through 15 or 17.
Okay, Harshita and Himesh, have you guys already gone through 15 and 17?
I joined whenever you were doing 6, so I haven't had like anything before that.
I've done 15, 17, and 20.
Okay, so you only need help with 25, right?
I need help on 25, and then I need help on 14E.
14E. Okay, so we'll do 14 D&E right now, and then because Harshita only needs 25, we can do 25 so that everyone can do 25. And then after that, we can go over 15, 17, and 20 for you and for Himesh and Himashi. And then after that, if we need to do any other homework problems or anything, we can go ahead and do that. All right, I think I gave enough time to everyone who wanted to join, right? Yes. Okay. Now 14D, Harshita, sorry, I've already said this a bunch, but bear with me because it's kind of hard to write with the mouse. So a lot of it's going to look a little wonky and I'm going to take a little bit extra time writing stuff. And if you need any help at any moment, don't hesitate to just unmute and say like, I don't understand, can you go back? Okay.
Okay.
All right, perfect. So 14D, binomial theorem to write a to the power 4 and b to the power 4. Again, 4 is in like the first 5 rows of Pascal's triangle. This is something that you should kind of like, you'll have used it enough that you'll know it off the top of your head. If you really have to, I guess you could fully expand it like n choose r times a to the n minus r times b to the r. I guess you could do that if you really wanted to. Seems kind of a waste of time if you ask me, but if it helps you, feel free to do it. Okay, a to the power 4 is equals x plus y whole to the power 4, whole to the power 4, whatever you want to say. Okay, this equals x to the power 4 plus 4x cubed y plus 6x squared y squared plus 4xy squared or 4xy cubed plus y to the power 4. For sake of time, all I'm going to write is b to the power 4 equals x minus y to the power 4 equals this minus this plus this. Sorry, this is just for the sake of time. I cannot write all of this again. And then plus this. Everyone get that? We understand how that works? Okay, great. And then we want to factorize a to the power 4 minus b to the power 4. Literally, basically what they're saying is, yeah, okay, sorry. Anyways, a to the power 4 minus b to the power 4. Sorry, I'm gonna try something out because this isn't how I did the homework, but now that I'm thinking about it, you could just technically write it like this. So a to the power of 4 can be rewritten as a to the power of 2, and then that whole thing to the power of 4, or to the power of 2, minus b to the power of 2, whole thing to the power of 2, right? So then you get it in the form of a squared minus b squared. Thank you. You get it in the form of a squared minus b squared. Oh, thank you. Right? So a squared minus b squared equals a plus b into a minus b. Again, this isn't how I did it, so this might not work out, but it should work out. So a squared in this case is literally a squared, and then b squared in this case is literally b squared. So you get a squared plus b squared into a squared minus b squared, right? And then we can rewrite this as a squared plus b squared because you can't re-expand that. So a squared plus b squared times a plus b into a minus b, right? And there you go. That's, or, well, I guess really if you wanted, you could further, or well, you probably should. You should further expand this into a cubed plus a squared b. That should be a 3. I'm just gonna reset. Boop. A cubed plus a squared b plus ab squared plus b cubed. Everyone see how we got that? We're just multiplying how you normally do, I guess. They taught FOIL, I think is how they taught it, right? So first, outer, inner, last. And then all of that times a minus b. You don't really have to multiply back in a minus b, but yeah. So there you go, you just factorized. Yeah, distribute. Like I said, sorry. He would like me to tell you, my brother, that it is distribute, not FOIL, which is basically what I said, but yeah, okay. Okay, for number, or letter E, everyone understands D, right? If not, we can go ahead and go back over whatever you guys need to go over.
Wait, how did you get a squared plus b squared?
Okay. So remember, a squared minus b squared equals a plus b into a minus b. So here, what I'm doing is I did the a squared squared minus b squared squared. So here I can just consider a squared to be a and then b squared to be b. So I have a plus b into a minus b. Now this is actually another difference of squares. So I just did a plus b and a minus b over here, and then I just distributed and then there's that. You get it? Or
Yeah, could you say that formula again?
a
The-
squared minus b squared, it's a difference of squares. It equals a plus b and a minus b.
Okay, thanks. Yeah.
All right, everyone else good? Or do we need to go over something? Okay. All right. So I'm gonna move on to E. Okay, so does anyone know what a conjecture is? Anybody? All right. I'm gonna assume that means that no one understands what a conjecture is, but a conjecture, all a conjecture is a pattern that you see. Okay? So over here. Okay. Over here, you can see a pattern because you've written out all of like every single one of the parts to the problem. You've already written that out. So here, we've shown that this equals a plus b into minus b. For part C, we've shown that that equals a minus b into a squared plus ab plus b squared. For part D, we've shown that a to the power of 4 minus b to the power of 4 equals a cubed minus a squared b plus ab squared plus b cubed into a minus b, right? So what's common between all of these is a minus b, okay? No matter what, you're always gonna have an a minus b. Now, what you're multiplying a minus b by is a to the power of n minus 1 plus a to the power of n minus 2 and then b to the power of 1 plus a to the power of n minus 3 b to the power of 2 and then plus and then dot dot dot. You keep going until you have plus a to the power of 1, a times b to the power of n minus 1 plus b to the power of, or n minus 2 plus b to the power of n minus 1. Like if everyone has the solutions on their paper, do they see how this pattern applies to every single one of the, every single one that you've just proved?
Okay, so I stopped paying attention in like the beginning for like 5 seconds, and now I have no idea what's happening.
Yeah.
So could you just re-explain that?
Yeah. Sorry, give me 1 second. It is currently tea time. Okay. So, Hamash, do you have all of the solutions for, do you have the solution for A, C, and D written out?
Yeah.
Okay. So do you see how A squared minus B squared, A cubed minus B cubed, and A to the power 4 minus B to the power 4, they all have a common term of A minus B, correct?
Yeah.
Now, everything, anything to the power of, so A to the power of n minus B to the power of n, I should probably write that, A to the power of n minus B to the power of n will always equal A minus B times A to the power of n minus 1. So like, for, like the one that we just did, right? A to the power of 4 minus B to the power of 4. What? Sorry, give me 1 second. Okay, sorry. I'll go one more time from the beginning, just so it like all connects. So we have A to the power of n minus B to the power of n. A minus B is always going to be common, as you can see from the pattern that you can see this in a pattern of everything that you solved from part A to part D, okay? Because A squared minus B squared equals A minus B, which is the common term, times A plus B. A cubed minus B cubed equals, sorry, my voice just broke, but A cubed minus B cubed equals A minus B, the common term, times A squared plus AB plus B squared. And then like we've just shown, A to the power 4 minus B to the power 4 equals A minus B, the common term, times A cubed plus A squared B plus AB squared plus B cubed, right? Now, what we can also see a pattern of is that you're always gonna have A to the power of n minus 1. So like over here, you have A to the power of 2 minus 1, which is just 1, plus, and then you're gonna keep going. So A to the power of n minus 1 plus A to the power of n minus 2b, n minus 2 times b to the power of 1, plus A to the power of n minus b plus times b to the power of 2, plus, and then you're gonna keep going until you reach A to the power of 1 times b to the power of n minus 2 plus b to the power of n minus 1. Does everyone see that pattern? If not,
Yeah.
yes? Hema, Harshita, you guys both see the pattern?
Yeah.
Okay. Hema, are you still there?
I don't. I'm so confused.
Okay. Is there a specific part that you're confused about? Or
I understand the whole A minus B and how it's like same in all of the answers we got.
Mhm.
Everything after the parentheses in the next part
Okay.
is just letters.
Okay.
I also have a question. I have a question where it goes from B to B squared and then you make it to Bn minus 2.
Yeah. Okay. So I think the easiest thing to show this would just be to use all the examples that we have. So A squared minus B squared equals A minus B. And this is the easiest way to form a conjecture, because a conjecture is literally, all a conjecture is a pattern that you observe that can be held true for every instance. Okay? So then A cubed minus B cubed. Sorry if my voice is cracking. I've been talking for a while now. But you have A minus B times A squared plus AB plus B squared. Correct? And then you have A to the power of 4 minus B to the power of 4, which is A minus B times A cubed plus A squared B plus AB squared plus B cubed. Oh, goodbye, Himesh. That's b cubed. Okay. Now what we can see as a pattern here is that the power of the first term is always 1 less than the overall power. The power of the second term will be 2 less than the overall power, and then the other number, or whatever you want to call that, is going to be just 1. And then the power of the third term will be 3 less than the power of the original term. And then you're going to have the second term to the power of 2. So on and so forth until you reach a point so that you have your first term to the power of 1 times your second term to the power of n minus 2, which is what we show over here, right? So over here, we have a to the power of 1 over here, and then b to the power of n minus 2. 4 minus 2 is 2, which is what we have over here. And then b to the power of 3 is b to the power of n minus 1, which is b to the power of 4 minus 1. And then we can see the same pattern over here, right? A squared is a to the power of 3 minus 1 plus a to the power of a minus 2, which is 2, and b to the power of 1. But this term over here is this term, but at the same time, it's also this term, because we keep applying this formula until we can reach such a term that your first term will be to the power of 1, and your second term will be to the power of n minus 2, and your last term will just be your second term to the power of n minus 1. Do we see that, or do we still not understand it? And if not, it's fine. We'll find a different way to explain it so that we understand. Yes, no, maybe so. Perhaps not.
Yeah, I get it.
Emma?
I get it.
Okay. And if you don't get it, don't hesitate to ask. I'm perfectly fine to re-explain it. We're fine. We have time. We're not constricted. Yes, no? Okay. Great. Now let's do Harshita, you said you wanted 25, right? And then Hema, you need 25. So then we can do 25, and then we'll Harshita, that way you can leave and we won't be wasting your time. And then Hema, we can work through any problems after that you have, okay?
Yeah.
Okay. Sorry, give me 1 second. Okay. That's fine. Do we have anything here? Oh, oopsie, I forgot to take screenshots. Too late. Okay. We wanted. Do you want to go through the entire problem of 25?
Yeah.
Okay. And actually these last 3 problems are questions that you might actually see on an actual IB exam. So those are IB exam style questions, which is why they give you 1 mark, because this entire question is worth 1 mark. This entire question is worth 2 marks. This question is worth 2 marks, and then this question is worth 3 marks. So then overall, this is a 4, 5, 8 mark question. And you get points for showing the methods and stuff. So even if you don't fully understand what you're doing, at least try. Like what my brother's always continuously been saying, just at least try to find a method, try to figure out what you're doing. And even if you don't fully understand, even showing the attempt that you did it will get you points. And my brother, he told me he was going to be really lenient with the test because he knows that we're obviously not IB students, so we don't really fully understand what's going on. But at least as long as we try, he'll be lenient and give us points. Okay, so we're gonna go through my notes just to make sure I am doing everything right. That is 20. Is it 25 on the back? Okay. Oh, so it's that question. This is a question that has permutations and combinations, which is not my strong point, but we'll make it work. Okay, 7 women and 2 men are chosen to sit in a row and have their photograph taken. So for these types of questions, Hema, you already saw this before, but what I like to do is, hello. Okay, sorry, my thickness is kind of off. That's fine, we'll just increase the thickness. Okay, instead we'll just do, okay, I see what happened. We're gonna make this smaller, and then we're just gonna increase the size. Oh God, Jesus. Oh dear. Okay, that's perfect. Okay, so Hema, you already saw this earlier, but Prashita, normally what I like to do for these kinds of problems is I like to state explicitly what information I'm given. So I'm given the fact that there are 7 women. So I'm going to abbreviate that as 7W. And I have 2 men, so I'll abbreviate that as 2M. They're chosen to stand in a row and have their photograph taken. How many different ways can they be arranged? So for a question like this, I like to visually see it. So I have 9 people in total. So I have 9 chairs. 1, 2, 3, 4, 5, 6, 7, 8. We'll fit in an extra chair over here. Okay. So for my first chair, I have a total of 9 options because it doesn't matter whether or not it's female or male. Because I've already used up 1 option here, I only have 8 options over here. I've used up another option over here. I only have 7 options over here. So on and so forth until you get to 1. So 6, 5, 4, 3, 2, sorry, that's weird. Then 1, which is just 9 factorial, right? So 9 factorial, again, if it's a no calculator problem and it's something like that, you can just leave it as 9 factorial. If you have a calculator, I would probably say, like, just write down the answer. So that's going to be 362,880. Oh, goodbye, Harshita. She good? Okay, we'll just keep working through the problem. It's fine. Okay, Hema, you understand?
Yeah.
Okay. Okay, now, part B. It says, how many ways can they be arranged if the men must sit together? So what I'm going to do now is I'm going to consider the 2 men as one entity. So now so I have the 7 women, and I'm considering this as like one entity. So I have 8 factorial now, so I have 8 options. But then within the one entity, you have male 1 and you have male 2. However, you could also have male 2 and then male 1, right? Which means that you're gonna have to also, which means that we also have to multiply whatever answer we get here by 2 because we have 2 factorial. Do you understand this or should we go back?
I got it.
Got it? Okay. 8 factorial times 2 is 80,640 apparently. 80,640. Excuse me. Now, part C. How many ways can I can't talk. How many ways can they be arranged if the men must sit apart? So now we have the total number that we have the total number of possibilities, and from that we're going to subtract every single possibility in which the men sit together. So we have 9 factorial minus 8 factorial into 2. Yeah, do you get how we got that?
Yeah.
Okay. Minus 8 factorial times 2, which should get you, sorry, I'm not writing in the line underneath just because I want to conserve space. 282,240. Okay, and then last but not least, we have part D, Part D is actually pretty hard. At least I think it's pretty hard. I didn't really understand it when I first read it. So I had to kind of go back and like really look at the problem. So it says, how many ways can they be arranged if there must be at least 2 women separating the men? So, sorry. Oh. Sorry, my mind just blinked out for a second. Okay. Anyways. Give me 1 second. I just want to make sure what I'm saying is actually right and I'm not just reading you complete nonsense.
Yeah.
Okay, so for part D, we have to take the number of total, like the number of ways that we can arrange them in total, which we got in part A. From that, we have to subtract the number of ways 1 woman can separate the 2 men, because that can't be the answer, right? Right?
Yeah.
That sounded like a very questionable yeah. Do we want to?
Just repeat that again. I don't think I completely got it.
Okay. So we want to take the number of total ways that we can arrange everybody. And from that, I want to subtract the number of ways that they can be arranged if there's only 1 woman separating the 2 men, correct? Because there has to be at least 2 women separating the 2 men. So if we have 1 woman separating the 2 men, it won't work. So again, to find the number of women the number of ways if there's only 1 woman separating the 2 men, I'm going to consider man and then woman and then man to be 1 entity, okay? So now we have 7, 8, 9 people in total. Of those 9 people, we just use 3 people. So in total, we have 7 options, right? Because we have 6 people, and then we're considering the last 3 people to be 1 entity. So we have 7 factorial because there are 7 options. But then, within this, out of any of the 7 women, any one of those women could be in there. So we have 7 factorial times 7 choose 1, which is just 7, but like it's sometimes it's good to write it out like that. And then the 2 men can, again, remember how we said it can be man 1, man 2, or man 2, man 1. There's 2 separate ways that the 2 men can be arranged in this scenario. So then we also have to multiply this entire thing by 2 factorial, which is just 2. Do you see how we got that?
Yeah.
Okay. So again, 7 choose 1 is just going to be 7. 7 times 2 is 14. So you have minus 7 factorial times 14. Okay. And then we also want to subtract the total number of ways that they can be arranged if the men have to sit together, because there has to be at least 2 women separating them, right? So we got that answer in part B. So I'm just going to write minus 8 factorial times 2. And then if you just plug that into a calculator, you should end up getting 211,680. We good? Do you want to go back to any of them, don't understand, or have any questions?
Where in the side where you wrote 7 choose 1,
Yes.
are we multiplying that with the rest of the writing?
Yeah, we are multiplying. So we're going to multiply everything. So we have 7 factorial because there are 7 options if we consider man, woman, man to be 1 entity. And then within that 1 entity, there are 7 different options for the women. So we multiply the 7 factorial by the 7 different options that we have for the women. Times, we have 2 different ways that the men can be arranged. So we multiply everything that we already have by the 2 different ways. So times 2.
Okay. And then we're getting the 8 factorial times 2 from the C answer.
From part B. Because part B is, remember, how many ways can they be arranged if the 2 men must sit together? Well, in this instance, the 2 men can't sit together, right?
Right.
So we have to subtract every instance in which the 2 men are put together. All right. Any other questions on this, or do you want to move on to a different question?
We can move on.
Okay. Should I take a screenshot of this? Do they deserve?
Yeah, maybe Hershita will want to, or like anyone who had Samir, because he didn't go over this.
Yeah. I'll just say, sorry, I forgot to do, take a screenshot of 14, blah, 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 but
Yeah, but Sarvam said the recording was fine, so.
okay. Mm. Mm. And read, not rad, read what there says. Feel free to DM me or text me. And see that I actually and to respond to me and is Parth in here? I'm so confused.
What is it?
Is Parth in here?
No.
Or is he just doing the problem separately and just saying that? Oh well. Either way, it doesn't much matter for me. Okay. What do you want to do next? You can do
We can
any.
do. I feel like I want to go 15 because everyone says it's really hard.
Oh wait, 15 actually isn't that hard. You just kind of have to take it step by step and then. What do you mean what happened to the 2 marks required for B? I literally. Whatever. He's being annoying. Oh damn, I'm recording this. Oopsies. Okay. Those are the 2 marks. Marks. Does it necessarily mean 2 steps? That's just how. Factorial times 2 could be considered as 2 steps. Therefore, it makes sense if it is 2 points. I don't think I've ever written on the Discord this much, because normally I just kind of stalk everyone. Okay. Excuse me. We wanted to do 15, correct?
Yeah.
All right. Bear with my voice too, because it's kind of just dying at this point. But we'll make it through.
You've been explaining the entire review. Don't even.
We'll make it through. Don't worry about it.
Yeah.
I will help you understand this if it's the last thing I do before I die. Okay. I'm gonna increase a little bit. I'm gonna put that right in the corner. Okay. Given that the coefficient, okay, bear in mind this is gonna take up quite a bit of space and it's gonna take up a lot of time as well because I have to write it by mouse, which would have been easier if I had a stylus, but like whatever. Does he not see that I literally said I forgot to take? Mm. Okay. Whatever. Okay. Given that the coefficients of x to the power of r minus 1, x to the power of r, and x to the power of r plus 1, and the expansion of 1 plus x to the power of n, 1 plus x whole to the power of n, are in an arithmetic sequence, show that n squared plus 4r squared minus 2 minus n into 4r plus 1 equals 0. So, give me 1 second. I keep my paper out now so I can like look at it, but so I can just make sure I'm showing you the right stuff, because I don't want to teach you the wrong thing or show you the wrong thing if that's not what you're supposed to do. We're starting here. And did I go back here for case 1 and case 2? Hence find the 3 consecutive coefficients of the expansion. Okay, great. Is there like a typing feature on here? Well, typing won't really help. Whatever, I don't care enough. Okay, what we're required to prove is RTP. Wow, it's nice and thick. I like that. Okay. What we're required to prove here is that the coefficients of blah 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 blah. We have to show that n squared plus 4r squared minus 2 minus n to the power of 4r plus 1 equals 0, given that, and then I'm just going to underline this, and then put an arrow over there so that I can fully experiment okay. Anyways, right. So if x to the r minus 1, x to the r, and x to the r plus 1 are in an arithmetic sequence, that means that the difference between x to the r and x to the r minus 1 is going to be equivalent to the difference between x to the r plus 1. Oh my god, geez. Sorry. That is not what I meant to say. Okay. Because the coefficients of x to the power, because the coefficients of x to the r minus 1, x to the r, and x to the r plus 1 are in an arithmetic sequence, that means that n choose r, the difference between n choose r and n choose r minus 1 is going to be equivalent to the difference between n choose r plus 1 and n choose r. Do we get that, or do we want to see it, or some other way?
Can you like visually show that to me?
Okay. So these 3 are this, and this are in an arithmetic sequence. I'm just gonna erase this. You get what I wanted to show, right?
Yeah, I got that.
Erase this. Is there a dog in the background? Okay. So, did you need something, Chris, or just?
No, we just hopped in here to raid the room because we finished.
Oh, okay. Okay. Sorry, give me 1 sec.
I now have to rewrite the entire thing.
Okay, so Hema, so what I'm saying is x to the power of r minus 1, x to the power of r and x to the power of r plus 1 are in an arithmetic sequence. That means that the difference between n choose sure, n choose r, no, whatever. That means that the difference between n choose r and n choose r minus 1 is going to be equivalent to the difference between n choose r plus 1 and n choose r. Do you understand how we got that?
I understood that.
Okay, great. So what we want to do first is we want to just, or you know what? Let's just go ahead and okay. Anyways, sorry, I'm eavesdropping. Okay. I'm just gonna move everything to one side, just to make life easier for myself. So I have 2 and choose. Hello. I have 2 and choose r minus and choose r minus 1 minus and choose r plus 1. Do we get how we got that? Okay. So now what I'm gonna do, I'm just gonna fully expand all of it. So over here I have 2 n factorial. Oh my god, I have to write all of this. Okay. 2 n factorial over r factorial into n minus r factorial. N minus r factorial minus n factorial over r minus 1 factorial times n minus r minus 1. R minus 1 is going to be in parentheses. The negative sign will distribute, so you have minus r plus 1 factorial, and then minus n factorial over r plus 1 factorial, and then again n minus r plus 1 will be in parentheses. Negative sign will distribute, so you get n minus r minus 1 factorial equals 0. Emma, do you get what we're doing so far?
Yeah.
Okay, perfect. We're gonna move down a bit. Okay, so now what I can do, sorry, we're good. Okay. Okay, we can take an n factorial common from all these terms, right? So I'll have now n factorial times 2 over r factorial times n minus r factorial minus 1 over, sorry, minus 1 over r minus 1 factorial times n minus r plus 1 factorial minus n factorial over r plus 1 factorial. Oh, sorry, that should be 1, not n factorial. R plus 1 factorial times n minus r minus 1 factorial. Equals 0. Now what we want to do, we want to divide both sides by n factorial to get rid of that, okay? So 0 divided by n factorial is just going to be 0. So you have now 2 over, okay, sorry, give me 1 second to figure out how I want to explain this next part. Okay. So what we're gonna do now is we want to find the least common denominator. Now the least common denominator, it sounds weird, but the least common denominator is actually whatever is the biggest, because whatever the biggest number is, you can multiply everything else by something to get that number, right? So take, for example, you have 1 over 60. minus 3 over 5, right? You don't want to break up 60. So instead what you're going to do, you're just going to multiply 5 by 12 to get 60. And then you're going to multiply the top by 12 as well so that it's proportionate. So you have, what did I say, 3 over 5? So you're going to have 3 times 12 over 60. 3 times 12 is what, 36? So you just have 1 over 60 minus 36 over 60. So that same thing kind of applies over here, where the greatest terms are r plus 1 factorial and n minus r plus 1 factorial. Because see, over here, everything has an r factorial or an r of something factorial. And everything has an n minus r factorial or n minus r plus minus something factorial, right? So the greatest of those are n minus r plus 1 factorial and r plus 1 factorial. So what I want to do is I want to figure out what I can multiply each of the denominators by to get r plus 1 factorial and n minus r plus 1 factorial. And what I want to do is multiply all the numerators by that number. So for the first part, okay, I'm just going to have one giant denominator of r plus 1 factorial times n minus r plus 1 factorial. One does not look like an n. Just going to make that there. It still doesn't look like an n, but oh well. Factorial. So now, what times r factorial equals r plus 1 factorial? Well, r plus 1 factorial can be rewritten as r plus 1 times r factorial, right? Yes, no, we understand that?
Yeah.
Okay, so that means that r plus 1 times r factorial equals r plus 1 factorial. So we want to multiply the top first by 2 times r plus 1. And then we can also multiply the denominator by, again, same concept, n minus r plus 1 times n minus r factorial equals n minus r plus 1 factorial. So we have the n minus r in common, so we're just going to put the n minus r plus 1 on the top over here. We get how we got that? Yes, no, maybe so?
Maybe so.
Okay. Do you have a specific part that you don't really quite understand, or do you just want me to explain the entire thing again?
Just explain it again.
Okay. So, do you understand the part about the least common denominator? Why that's
Yes.
okay. So what we're doing is we found a least common denominator. Now we're trying to see what this denominator times what is going to get me to the least common denominator so that I can make the original fraction proportionate to this new fraction, given that we have a new denominator. Do you get that?
Yeah.
So like, remember the example I gave before of 1 over 60 times, or 1 over 60 minus 3/5?
Yeah.
We multiply 5 by 12 to get to 60, right? So we want to multiply the numerator by 12 as well, so that we our new fraction is proportionate to the old fraction. Do you get that?
So right now, like using the example, we're just trying to find out the 12 and multiplying it to both.
Basically, yeah, exactly. That's exactly what we're doing now.
Okay.
The only difference is this is a bunch of letters and 1 or 2 numbers, whereas that's just like pure numbers. But the same concept applies here. Because r plus 1 factorial is just r plus 1, like we already established, right? You understand this, because I know you do. But r plus 1 times r factorial, correct? And over here we have r factorial, so the r factorial doesn't matter here. What matters is what we multiply r factorial by to get r plus 1 factorial.
Okay.
And then the same thing over here. We have n minus r plus 1 factorial, which can just be rewritten as n minus r plus 1 times n minus r factorial. Again, we have the n minus r factorial right over here. So this one doesn't matter, that cancels out. And instead, what we're left with is n minus r plus 1, which is what we're multiplying the numerator by.
Okay.
You get that?
Yeah.
Okay. Now all we're gonna do is apply the same concept to the rest of the terms. So we have okay, r minus 1 factorial, right? R plus 1 factorial can be rewritten as r plus 1 times r minus 1 factorial, right?
Right.
So r minus 1 factorial, we can cancel that out with the denominator. So all that's left in the numerator is r times r plus 1. Do we get that?
Yeah.
Okay. And then same thing over here. Sorry, the n minus r plus 1 factorial over here doesn't matter because this is the same thing. So that just cancels out. And then
Okay.
again, r plus 1 factorial, same thing, cancels out. N minus r minus 1 factorial, n minus r plus 1 factorial can be rewritten as n minus r plus 1 times n minus r times n minus r minus 1 factorial. So the n minus r minus 1 factorial will cancel out, and all that's left on the top is n minus r plus 1 times n minus r. Do you get that?
Yeah.
Plus 1 times n minus r. And I've been struggling with this for like the past 3 or 4 days, and I think it's just because I'm just tired, but I couldn't process anything.
Wow. It is a little confusing, but I think I get it.
Is there a specific part that you're kind of confused about? Because we can rework it. Don't worry about time or anything like that. If you need the help, we'll give you the help.
I don't know what I'm confused at, but I'm not grasping it as easy as I did with the others, basically.
Okay, can you annotate the screen?
I don't think we have that option.
You can't annotate? Oh, that's sad. Okay. Now can you annotate?
Oh, yeah.
Okay. So what I'm gonna do, I'm gonna put a giant white block over this, and then I just want you to work out the problem by yourself, okay? We'll put the giant block, red block or giant white block over this, okay? Or this
Okay.
block. And then I want you to rewrite the problem, and we can go step by step. Wherever you don't understand what's happening, I'll explain it to you, okay?
This is gonna go very bad, by the way.
No, don't worry about it. Don't worry about it. We'll figure it out, okay?
Okay, so we do the whole like common denominator thing to find out. Wait, it's blue. You can't see anything.
It's fine. I can hopefully change the color of this.
No, I got it. I turned the
Oh,
color.
no. Whoa. Okay, there.
Okay. I am so bad at this. Okay.
I know,
we
it's kind of hard. You just get used to it.
You have the largest common denominator, I guess.
It's called the least common denominator because I did. Shoo, this is mine. Leave, be gone. Okay. Anyways. Older brothers, what are they for except to annoy you and help you? But mostly annoy you. And yes, this applies to you too. Anyways.
Okay. I got until this point, right?
Yeah.
And then we have to basically multiply this bottom to the top. And we have 2 r plus 1, if I'm right.
Yes. Now, do you understand why it's r plus 1?
Yeah, because we're just
That's the more
multiplying the numerators with the denominator.
Yeah. Basically.
And then we do the same thing here. Oh my God, there's so much to
Okay, you
write.
say you're multiplying the numerator by the denominator. That's not exactly what you're doing. You're saying, sorry.
Yeah.
We're saying what number, or we're saying what will multiply with the denominator to get you to this new denominator. And then we're just multiplying the numerator by that so that we have a proportionate fraction to whatever we had before.
Nothing went through my brain, that one.
Okay. You have, we'll just do this. You have r factorial times n minus r factorial in the denominator, right?
Yeah.
Oh my, what is up with you today? Like, why? N minus r factorial, right? We want to get this to a new denominator of r plus 1 factorial. Like maybe this will help you see it better just because it's like literally right side by side or like underneath, whatever.
Right.
Excuse me. Times n minus r plus 1 factorial, okay? Now the reason we want to take the greatest thing that any of these can multiply to is because, especially since it's a factorial, we can just break it apart and then we can cancel stuff out. So like over here, r plus 1 factorial can just be rewritten as r plus 1 times r factorial. But see, we already have the r factorial in the denominator. We want to figure out what times r factorial will get you to r plus 1 factorial. Well, r plus 1 times r factorial will get you to r plus 1 factorial. So you multiply the numerator by r plus 1 factorial. And then you take the next term. N minus r plus 1 factorial can be rewritten as n minus r plus 1 minus r plus 1 times n minus r factorial, right? Because this minus 1 factorial will get you to this. Now we already have n minus r factorial in the denominator. We want to figure out what times n minus r factorial will get us to n minus r plus 1 factorial. Well, in this case, n minus r plus 1 will get us to n minus r plus 1 factorial. So we also want to multiply the numerator by this so that we have a proportionate ratio, a proportionate fraction to the fraction that we had before.
Okay.
Does that make more sense?
Yeah. That
Wait,
makes so
how are
much
you
more sense.
still explaining this problem?
Stop talking.
Shut up. She's just
I went
taking
out
a
to.
while.
No, not her. I mean you.
Because I'm helping her understand the problem. I can
Okay,
explain the problem, but just because I explain it doesn't mean she understands it. I want her to understand what's going on.
Okay then.
You go play Minecraft or whatever you do.
I went to get dinner.
Okay, then go.
And then I ate dinner and came back and you're still here.
Okay, but go play Minecraft or whatever. Or do your pages for Rash's homework that I haven't done yet. But
Wait, when does that do?
I did it all. For your information, I did all of it. I'm just waiting on you.
I'll get my pages to you by Wednesday because I don't really understand what he wants. Anyways, back to math. Sorry. Okay, and then Hema, can you I don't know why I have to do anything like that, but Hema, my mouth is wrapped. But okay, can you do the rest of the problem?
You're just bad at explaining.
Shut up, Park.
No, she's not. I'm just really dumb,
She
basically.
speaks
not
too
dumb.
fast. No one understands her. It's not you. She just speaks too fast.
Stop talking.
Too bad.
Oh. Do I have to write the entire thing out? It's so long.
Oh, is it hard to write?
Yeah. Okay, and then basically this over here, and then just this part here.
Yeah. Okay.
Yeah.
So you understand. Perfect. I'm just gonna clear your annotations and then oh, perfect. Okay, I'm gonna go ahead and delete this shape. Okay. So now what we want to do is we want to just fully explore. You know what? First thing we can do is just multiply both sides by r plus 1 factorial times n minus r plus 1 factorial to get rid of your denominator. So you should end up with 2 times r plus 1 times, oh my god. Okay, 2 times r plus 1 times n minus r plus 1 minus r times r plus 1 minus n minus r plus 1 times n minus r equals 0. Now, what we're going to do is we're going to fully expand this equation, and we're just going to, yeah. So we have 2r. I'm just going to erase this and rewrite this as 2r plus 2, just so I don't have to write an extra line. So you have 2r plus 2. Okay, 2r times n is 2rn times, is that an r? Yes, it's an r. Oh my god. Ugh. There, 2rn, that's going to be minus 2r squared plus 2r plus 2n minus 2r plus 2. We're going to move over a bit just so we have some space to write it. Plus 2. Okay, minus r squared, because r times r, minus r. No, we have, I'll just rewrite this as, well, we're just going to do it on our head, but that's going to become minus r, that's going to become minus n, that's going to become plus r, and that's going to become minus 1. So minus n times n is negative n squared. Minus n times minus r is plus nr. Positive r times n is plus rn, or we're going to rewrite nr as rn just so it's like it doesn't confuse us when we combine the like terms. But plus rn, rewrite. Okay, whatever. Rn, and then plus r times minus r is going to become minus r squared. Minus r squared. Minus 1 times positive n minus n, and then minus 1 times minus r is plus r. Okay, equals 0. Now we're going to combine like terms. We have 2rn. Any other instances of rn? Okay, so plus rn becomes 3rn, plus rn becomes 4rn. 4rn. Okay. Minus 2r squared. Any other instances of r squared? So that should become, I want to say minus 4r squared, right? Because minus 2r minus r squared is minus 3r squared, minus r squared is minus 4r squared. And then plus 2r, plus 2r minus 2r are going to cancel. Any other instances of r? Okay, we have a minus r, and then we have another minus r. Or, what did I say? Oh.
Minus r and plus r, right?
Yeah, so you should get minus r. But did I do something wrong? I think I did. This 2 and minus 2r should cancel. So after the minus 2r plus 2 minus, oh, because that says minus n squared. Oh, yeah. Wait. Sorry, something went wrong just because all the n's and r's look the same here. So it's kind of hard for me to tell what I actually wrote.
Okay. Based on what I saw with your handwriting, I got minus r plus r though.
Yeah, we're just gonna re-expand this.
Okay.
And you know what? I'm just gonna type it up just because I cannot deal with writing it.
Yeah, that's fine.
So like r squared, I'll just do r to the power like r, and then yeah, okay. Sigh. Okay. So we're gonna make that a little bit bigger. Okay. So you have 2r. So you should get 2rn minus 2r squared. That's a b. 2rn minus 2r squared plus 2r plus 2n minus 2r plus 2 minus n squared plus nr minus n plus nr minus r squared plus r minus r squared plus r minus r squared minus r. That should have been what we got. We're gonna add spaces in between so we can differentiate between all the different terms. Or yeah. Yeah, and sorry about my voice, but it's just kind of dead. So yeah. Okay, now are we confused about any of this?
No.
No? Okay. Okay. So we're gonna rewrite the nr as rn just so it's like just to make life easier for us. Okay. Oh my god. Excuse me. Okay. So what you should end up getting is 4rn minus 4r squared. That's a b again. Should be an n. Minus 4r squared plus n plus 2 minus n squared equals 0. Okay. I do. Okay. So now we want to get it to the exact form that they give us, which is n squared plus 4r squared minus 2 minus 4 or what? N squared plus 4r squared minus 2 minus n times 4r plus 1. Do you see how you could get from this to that?
Yes.
Okay. So then we're not going to work that out just for the sake of time.
Yeah.
Hence, find 3 consecutive coefficients of the expansion of 1 plus x to the 14, which form an arithmetic sequence. So now, your n in this case is 14, right? Because you have 1 plus x to the 14, I think is what they said. I hope is what they said.
Yeah.
Okay, so you have 1. I'm just gonna write that out. 1 plus x to the power of 14. In this case, your n is 14. So we're just gonna substitute in 14 for all of this. And then, what was I gonna say? I was gonna say something. What was I going to say?
You don't have to go through that. Just
Okay. But either way, you substitute in 14 for n, so you should get 14 squared plus 4r squared minus 2 minus 14 times 4r plus 1 if you look at the equation that you should have gotten at the very end of the beginning of this. And then you move all terms to one side, make that into a quadratic equation, and then solve using the quadratic formula. Or if you want to use a different way to solve, you can solve using that. And then you should get your two answers for R should be 5 and 9. So then again, you use the case 1 and case 2 thing. For case 1, you should, well, either way, regardless of which number you use, you're going to get 1001, 2002, and 3003 as your three arithmetic coefficients. Yeah.
1001 and what?
1001, 2002, and 3003.
Okay.
Okay, we good?
Yeah.
Okay, I'm gonna go ahead and erase all this.
You're finally done.
Stop.
Okay, do you have any other problems you want to go through? I think if we want, we can go through 17 and 20 if we make it quick.
Yeah, I think there's only 17 and 20 left. Are they smaller problems?
Yeah, they're pretty small problems.
20's pretty small.
Yeah,
17
That's
kind of gets
17.
confusing.
not really. 17 is really small. If you
I
do
mean,
it.
it's small, but it's kind of confusing to explain. And considering you took that long to explain 15,
Okay. No one asked for your opinion.
I didn't
Okay.
ask for your opinion on my opinion. So,
Class, please shut
Well,
up.
I didn't give it to you.
what?
Okay. Anyways, I forgot to screenshot. Do.
Can you not just look at the recording? Oh, you
Recording?
stopped recording. Oh,
What do
you
you-
mean the screenshot of the question? Never mind.
Yeah. Huh? No, we're doing the last two people. They're really small, so I'm tired.
How long has this meeting been going on?
I don't know, but my voice
Like
hurts.
3 hours, I think.
We were
My
supposed to
throat
start
hurts.
at 4:45, but there
No,
was
it's
like some
because
issues with the Zoom.
Samir didn't go through all of his problems, so I am trying to do the last couple of problems for anyone who didn't get it because he didn't
Oh damn,
understand.
Jacob came back.
So
You guys are gonna be very well prepared for the test. This is like above.
Hope-
I had to go eat dinner real quick.
Yeah, I ate dinner,
Oh,
came back,
yeah,
and she was
food.
still explaining.
food, what's food? I don't know what food is.
Kunda, be quiet. You eat dinner at like 10.
Okay.
No, you eat dinner at 11.
No, shush. I want to get through this. Okay. And that way, any other questions, we'll just quickly go through it and then be done. Okay.
Why am
So
I
yeah.
still here?
I don't know, because you like torturing yourself. I don't know. Anyways, so you have 3 plus x times 4 minus 2x to the power of 8. So you want to find the coefficients of the term of, you want to find the coefficient of the term in x to the power of 5. So what we're going to do, we're going to split up 3 plus x, and then we're going to do 3 times 8 choose 5, so that your x term will be 5 in this case.
Sorry, my brother just barged in and I got scared. Give me a second.
Okay, don't worry about it. Tell me when you're back on.
Wait, did
Is
anyone
there a
else?
correct way to write n choose r? Like, is there
Yeah.
a specific format that's usually used, or is it just both
There-
the parentheses version and n choose r are used?
Yeah, both the parentheses
Hand in
version and
hand.
parentheses are used. I like using the parentheses, especially when I'm like writing it out, just so I can see what's on the top and what's on the bottom, just because it makes.
I mean, you can do that with n choose r
Yeah.
too.
Yeah, you can do that with that too. It's just
The
really
first time I saw n choose r, I was so confused because I've never seen anything like on the top. It's usually always been on the bottom.
Oh, really?
Yeah,
Interesting.
both sides were on the bottom.
Also, did anyone else schedule get changed?
Yeah, my 2B web design.
Yeah,
Same.
kind of depressing.
I'll miss that web.
Goodbye, OP web class. Like half the people left.
I swear, if they if I schedule gets changed one more time, I'm actually gonna like, oh no.
Imagine me and Jake still have 8 classes together after this.
Okay, here's the thing.
Wait,
Since
they're
y'all
changing the schedule?
They
Yeah.
already
your
changed it.
schedule, if your schedule got changed, it got changed. It's not. It shouldn't change again. Hopefully, and also part two.
Hopefully.
Considering that
Mine
you and
hasn't
Jake
changed.
have 8 classes together already, it's even much harder for y'all to get into different classes now. You know what I mean?
True. I'm gonna check anyways.
Also, Kunda, there's like no one in our chem now.
Really?
Yeah, there's
Hey.
like a lot of people got not a lot, but there's some people got moved out, and I don't think our chem class needed people moving out, bro.
Thank God I still have the same classes.
You're lucky.
Must be nice.
Except, you know what? I really want to change my study hall.
To what?
I don't know. I heard 4A was good, but I have 4A world history. And that world history is pretty good.
The only other option is 1B.
Yeah.
And yeah.
Our 1B isn't that bad. It's not too bad.
Okay.
I mean, we have you, me, Jay.
Parth, I love you, but literally, please shut up. I'm so tired. Are you? You're back? Good?
I'm back. Yes.
Okay. Okay. So because 3 doesn't have an x next to it, we want to find x to the power of what is gonna end or Jesus. Calm. Okay. So remember when we said n choose r, like for any term in a binomial expansion, you're gonna have n choose r times a to the power of n minus r times b to the power of r, correct?
Yeah.
Okay, so b in this case is 2x or negative 2x. So negative 2x to the power of what equals is gonna end up with a coefficient for the term of x to the power of 5.
I'm so confused right now. You said things.
Okay, because 3 doesn't have an x next to it, we want to find the coefficient of x to the power of 5. So remember when we said n choose r is going to equal a to the power of n minus r, or n choose r times a to the power of n minus r times b to the power of r, right?
Right.
So in this case, b is negative 2x. So we want to find negative 2x to the what will result in giving me the coefficient of x to the power of 5. So I just have to have an x to the power of 5 in there. This to the power of what will get me an x to the power of 5?
No idea.
Is it just because it's late, or do you genuinely not understand?
I'm so tired. I'm trying to understand as you go, as you tell me.
Okay, that's fine. X to the power of 5, right? That's what we want.
Right.
So negative 2x to the power of what will get me something with x to the power of 5?
We just put the power of 5 on top?
Exactly. Perfect. See? Perfect. So now we have no, don't worry. But n in this case is 8. If you can see it, it's really tiny here, but 8.
Yeah.
So you have n choose r. R is 5 because we want to get to x to the power of 5. So we have a, in this case is 4. So 4 to the power of 8 minus 5, which is 3, times negative 2x to the power of 5. And then we want to add to that, because it's 3 plus x, we want to add to that x times 8 choose. Now here, because we already have an x, we just want to get this to x to the power of 4, right? So what number will get us to x to the power of 4?
We put the power of 4.
Exactly. Perfect. So we have x to the x times 8 choose 4 of 4 to the power of 4 times negative 2x to the power of 4. Because then when you multiply these, you'll get the coefficient for the x to the power, for the term with x to the power of 5. Do you understand that?
Yeah.
Okay. So now all we're gonna do is expand. I should probably write an equal sign there. But but all we're gonna do is expand, and you'll get 3 times 56, because 8 factorial over 5 factorial times 8 minus 5, which is 3 factorial. You'll end up getting 56.
Okay.
4 to the power of 3 is 64. And then negative 2x to the power of 5 is negative 32x to the power of 5. Excuse me. And then plus, we already have x. 8 factorial over 4 factorial times 8 minus 4 factorial is going to get you 70. And you can do the math with this later if you want. 4 to the power of 4 is 256. And then lastly, negative 2x to the power of 4 is 16x to the power of 4. Now we're just going to multiply. Now see how we have 16x to the power of 4 and x? That's going to get me the coefficient for x to the power of 5, because x to the power of 4 times x is going to equal x to the power of 5. So, yeah.
Yeah.
Which is why we wanted to find what to the power of something will equal x to the power of 4 over here. But we wanted to find x to the power of 5 over here because 3 doesn't have an x, so we can't multiply it to x to the power of 4. Anyways, what you should end up getting is negative 344,000. Wait, what? Yeah, negative 344,064 x to the power of 5 plus 286,720 86720 times x to the power of 5, and then you add that and you should get negative 57344. Negative 57344 x to the power of 5. Therefore, the coefficient of the term in x to the power of 5 and the binomial expansion of blah 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 is this number right here, right?
Right.
You get that?
Yeah.
Any questions? Are we good?
We're done.
Okay. And last question. Freedom. Okay. Ahel, did you have any last questions that you needed? Or
He said no, by the way.
we already went over 25 actually, but if you want, after we're done with everything, I can go back to 25 and then go over that. Good? No, it's fine meaning yes, or no, it's fine meaning no. Okay. Are you sure? Because if you want, I can always work it out. It's not too hard of a problem, so it won't take a horrible amount of time.
25 is pretty easy to explain.
Yeah, 25 is pretty easy to explain. So if you want, I can. I will.
Okay.
Okay, let's get through the problem that we're doing right now, and then we'll see.
Did you literally do the entire summary and review?
Yep. We went all the way from 1, and then just kept going. Because the people who were here for the very beginning never got to go to Samir's to do 15 or 14 onwards or whatever it was that he did.
But the only person here was Hema.
Well, Hema was here, and then I think Hamesh was here, and a couple of other people were here too. So.
But okay, never mind. I understand now.
Yeah, and then Samir never got to go through 14 D&E because he wasn't really sure how, or 25 because he wasn't really sure how, and then he didn't do 20 either because I think the one person that he had in his breakout room already did it. So he did
Kunda, I was gonna ask you to do a to the power of 5 minus b to the power of 5.
A to
But
the
you
power.
seem so dead.
I'll do it if you I'll do it if you want me to. I'm fine. Don't worry about it.
It's not a question. It's just a to the power of 5 minus b to the power of 5.
Okay, that's gonna be a minus b times a to the power of
no,
4.
you need to prove it. like using the same methods in
Well,
14
I
A, B,
already
C,
showed you I already proved it. I already proved the conjecture in 14 D.
not by not using the
E.
conjecture.
Okay, so then okay.
Why are you trying to torture her?
Like
She tortures herself.
okay.
Oh, two wrongs don't make it right.
True.
I mean, if you want to consider, sorry, I'll get to 20 in a bit, but if you want to consider,
No, just do 20. I'm gonna leave now anyway.
okay. But like really though, if you want to, okay, whatever. Yeah, okay, whatever. Anyways, prove the binomial coefficient identity that n choose k equals n minus 1 choose k plus n minus 1 choose k minus 1. Okay. Sorry, give me one sec. Okay. So we have this blah blah blah. Or if it helps you see or understand better, you can rewrite it as n choose k equals n minus 1 choose k plus n minus 1. You can still understand me, right? Because my throat just kind of died. But I'm like,
No, I can understand.
Okay, good. N minus 1 choose k minus 1. Okay. So then your left-hand side in this equation is LHS equals n factorial over k factorial times n minus k factorial. You understand how we got that, yes?
Yes.
Okay. And then your right-hand side of the equation is going to equal n minus 1 factorial. How have we already been at this for 3 hours or almost 4 hours? Damn, okay. But you're going to have n minus 1 factorial over k factorial times n minus 1 minus k factorial, or you can just rewrite that as n minus k minus 1 factorial, just because I feel like it. But actually it'll help later on, I swear. But and n minus 1 factorial over k minus 1 factorial times n minus k, or n minus 1, and then remember it's minus in parentheses k minus 1 factorial. The negative sign will distribute, so you have minus k plus 1. Minus 1 and plus 1 will cancel out, so you just have n minus k factorial. Okay. Now, one thing you can do, or you know what? We're not going to do that. Okay. Anyways, remember how we said the least common denominator is actually whatever is the greatest?
Yeah.
In this scenario, what's going to be your least common denominator?
And minus k minus 1 factorial.
Okay, so what's bigger, n minus k or n minus k minus 1?
N minus k.
Correct. So what's going to be your least common denominator?
N minus k.
Okay. And then between k and k minus 1, what's bigger?
K.
Correct. So what's going to be your entire least common denominator?
K factorial and n minus k factorial.
Perfect. See, you're getting it. So we have all over one joint denominator. How did I just make that straight? Okay. Anyways, you have k factorial times n minus k factorial. And then remember what we said when we have to find what multiplies with the denominator to get you, what multiplies with the old denominator to get you to the new denominator. So n minus k factorial can be rewritten as what? N minus k times n minus k minus 1 factorial. So all you have to do is multiply n minus k. So now you have n minus k. Okay. You have n minus, how are people still joining? You have n minus k times n minus 1 factorial, right?
Right.
And then you have plus N minus k is common here. So now we just have to pay attention to the k, right? K times what is going to equal, or k minus 1 factorial times what is going to equal k factorial?
I'm sorry, what was that?
K minus 1 factorial times what will get you to k factorial?
K minus 1 factorial. Plus 1?
No, because remember we want to break apart the bigger, whichever is the bigger number, and then like we want a factor of whatever is already there. So you can rewrite k as k times k minus 1 factorial, right?
Yeah.
So given that, what do you multiply k minus 1 factorial by to get you to k factorial? Do you need to see it? Sometimes it helps. Okay. You have k factorial, right? We can rewrite this as, because of the fact that if you have n factorial, you can rewrite that as n times n minus 1 factorial. We can rewrite this as k times k minus 1 factorial, right? So what do we multiply k minus 1 factorial by to get to k factorial?
We multiply by.
You have k minus 1, yeah, you multiply by k. Because you have k minus 1 factorial over here. You already have that in the denominator. You don't have to worry about that. What we want to find is this times what will get you to the new denominator. Well, this times k will get you to the new denominator. So now you have k times n minus 1 factorial. And now what we can do is, because both terms have a I was going somewhere with this, I swear. Oh, sorry. Okay, I know where I was going with this. Okay. Okay, now what we can do, we can distribute n minus k to n minus 1 factorial. So we have now n times n minus 1 factorial minus k times n minus 1 factorial plus k minus n minus 1 factorial. I mean, plus, oh my god, Jesus, what am I writing? Plus k times n minus 1 factorial all over k factorial times n minus k factorial. Okay?
Okay.
You see how I got that? Or do you need?
Yeah.
Okay. So now minus k and plus k, and because if you really don't understand why these cancel out, just consider n minus 1 factorial to be x. So you have minus kx plus kx. Those are going to cancel out, right?
Right.
So all you're left with is n times n minus 1 factorial over k factorial times n minus k factorial. Now remember what we said, that n factorial is equivalent to n times n minus 1 factorial?
Yeah.
Okay, so what is this? What can the numerator be simplified to?
Just n factorial, I think.
Yeah, n factorial. Perfect. And then you have k factorial times n minus k factorial. Now look, your right-hand side is equivalent to your left-hand side, right?
Right.
So here we go. We're just gonna go down a bit again. So we can write what we can write now is n factorial over k factorial times n minus k factorial is equivalent to, again, excuse me, n minus 1 factorial over k factorial times n minus k factorial, which implies, that the left-hand side equals the right-hand side. as you're required to prove, as RTP. And that's it. Congratulations, you've just gone through the entirety of
That took only 4 hours.
only 4 hours.
Thank you so much. I will be forever in depth.
Don't worry about it. All right, Ahel, do you still want to? Oh, is Ahel still here? Oh, Ahel, do you still want to go over number 25? Maybe. Oh no. Oh no. Okay. Hamesh, do you have any problems you want to go over?
Could you do number 5?
Number 5. Okay. Oh, where are you? Where's 5? Do you want 5A and 5B, or do you just want one of them? I can do either or, I don't really mind.
Both.
Both? Okay. Okay. So we want to prove the following identities. So for 5A, oh, that's really thick. I don't know if I like that. I'm gonna go down a thickness, like 2. Okay, so for 5A, we have n plus 1 choose 2 is identical. Remember the 3 lines means identical to n choose 2 plus n. So what I'm just gonna say what I would normally write just because I don't really feel like writing it, but normally I just write RTP, which stands for required to prove. So what you're required to prove here is that n plus 1 choose 2 is identical to n choose 2 plus n. So what I want to do in this kind of problem is I want to fully expand out the left-hand side of the problem, and then I want to fully expand out the right-hand side of the problem. And then I want to make sure that the left-hand side and the right-hand side are completely identical. And by doing that, I'm going to prove that whatever it says is true. All right, so I'll just start with the left-hand side. Left LHS, again, we've mentioned before, shorthand for left-hand side. But you can, I'm just going to rewrite this as n plus 1, choose 2. I don't know why I wrote that. Should be an equal sign. And which equals n plus 1 factorial over 2 factorial, which is 2 times 1, so it can just be rewritten as 2, times n plus 1 minus 2 factorial, right? So n plus 1 minus 2 factorial is just n minus 1 factorial. Right? I'm gonna leave that as is for now. If we need to expand it further later, we can do that. But for now, I'm just gonna leave it right as is. Or what do those do? Do I want to leave it as is? Yes, I want to leave it as is. Just because, okay, so I've already done the problem, so I know that you'll end up having to expand it further. But if you didn't know like how to do the problem beforehand, you wouldn't know that you have to expand it further. So we're just gonna leave it as is for now. Instead, we're gonna look at the right-hand side now. Now the right-hand side of the equation is n choose 2. We're gonna write it like that, plus n, okay? Why did I write that again? That should be an equal sign. Okay, now, sorry. Okay, n choose 2 can be is n factorial over, again, 2 factorial is just 2 because it's 2 times 1. 2 times n minus 5 factorial, n minus 2, in this case, factorial, plus n. Sorry, give me 1 second. Okay. So, what you have now, trying to figure out how to explain it, because I know how to explain it, but you know what, we're gonna go ahead and expand this further. So what can n plus 1 factorial be rewritten as? Well, there's the well, you have that n factorial is equivalent to n times n minus 1 factorial, right? So n plus 1 factorial can be rewritten as n plus 1 times n factorial, or you can do n plus 1 times n times n minus 1 factorial, right? And then you have all of that over 2 times n minus 1 factorial. Now this is nice because it allows us to get rid of the factorial, so that all we're left with is n into n plus 1 factorial over 2. Now what I want to do, I'm trying to do the same thing over here so that I can get rid of the factorials. So n factorial can be rewritten as n times n minus 1, right? That should not say factorial, sorry. N times n minus 1 times, oh my god, geez, times n minus 2 factorial, right? Do you see how we're getting to that in both instances? Smash? Yes, no?
Yeah, I get it.
Okay, good. I'm just making sure. Okay, and then on the bottom, you have 2 times n minus 2 factorial. Again, you can cancel out the factorials from both the numerator and the denominator, so that all you're left with is n times n minus 1 over 2, right? Now, this isn't quite equal yet. So what we're going to do, we're just going to re-expand the n into n minus 1, okay? So when we do that, we get n squared minus n over 2, right? Am I doing that right? Making sure. Oh, I know what's wrong, because I forgot to add the plus n. There should be a plus n over here. Plus n equals that plus n. Now, I want to get n into the numerator, so I wanted to multiply n by the denominator. So n times 2 is 2n, right? So this way I can have plus 2n on the top. Now, what I can actually do is I can, sorry, give me 1 second again. Oh, I don't know why. Okay, sorry, my mind stopped working for a second. Okay, so now negative n plus 2n is just positive n, right? So that equals n squared plus n over 2. Now what we can do, we can just factor out an n from the numerator, and you get n times n plus 1 over 2. Now, looky here, we have this side is equivalent to this side. So now we're just going to rewrite, okay. There has to be an easier way to do this.
Wait, so where did you get the plus 2n from?
So plus 2n, remember we have n choose 2 plus n? If we want to put the plus n onto the numerator, right now we have n over. Do you remember how to add fractions?
How to what?
How to add fractions. So like if you have 1 over 5.
Okay, so I think I know what you're doing
3,
now.
then you multiply 3 by 5 so that you can just put 3 onto the numerator of 1 over 5.
Yeah,
and then
common denominator. Yeah,
it's literally exactly like that, just with letters.
Okay.
Can you copy this? Oh, perfect. So what I'm gonna do, I'm just gonna copy paste that. And then you have that. That should not be there. Ignore that. And then that is equivalent to itself because that's the left-hand side and that's the right-hand side, and they are the same thing. Therefore, again, we're just gonna ignore. We're gonna ignore that. And ignore that. Okay, now you've shown that the left-hand side equals the right-hand side, so all you have to do now is say, therefore, LHS equals RHS as required to prove, which you can just say as RTP. So LHS equals right-hand side, or, well, actually, you should just say that the left-hand side is identical to the right-hand side as required to prove. Okay, do you understand everything here?
Yeah.
Okay. So now we're gonna go on to the next one. What was it? And choose two, right? Yeah, okay. So again, normally I'd write what you're required to prove is n choose 2 times n minus 2 choose k minus 2 is identical to n choose k times k choose 2. I don't feel like writing that right now just because it's been a long day. But you can visualize it in your mind. Anyways, so I'm just gonna rewrite this as n choose 2 times n minus 2 choose k minus 2 is identical to n choose k times k choose 2. Now again, same thing. I'm going to start out with my left-hand side and I'm going to fully extend it. So I have n factorial over 2 times n minus 2 factorial times n minus 2 factorial over k minus 2 factorial. If at any point you don't understand what's going on, just stop me. Over k minus 2 factorial times n minus 2 minus k minus 2. So you get minus k plus 2. Plus 2 and minus 2 will cancel out. So all you have on the denominator is n minus k factorial. If I multiply that, numerator and denominator, the n minus 2 factorials from both the numerator and the denominator will cancel. So you get n factorial over 2 times k minus 2 factorial times n minus k factorial. Now, I don't know if I have to simplify this further or what. So I'm just going to leave it as this for now, and then we'll revisit it after we extend the right-hand side. Now, the right-hand side of the equation is n factorial over k factorial times n minus k factorial. K factorial times n minus k factorial times k factorial over and no 2 factorial again, which is just 2 times 1, so you can just write 2 times k minus 2 factorial. And now the k factorials from both the numerator and the k factorials from both the numerator and the denominator will cancel out. So all you have now is n factorial over n minus k factorial times 2 times k minus 2 factorial. Now you can see here these are identical, but what we want to do in a proof is we want to show that the two sides are exactly equal. So I'm just going to rearrange the denominator of the right-hand side so that it looks exactly like the left-hand side. Sorry, I'm just copy pasting. I can't write again. I literally don't have the energy, but that equals that. That almost, okay, so that equals that, right? Therefore, your left-hand side equals your right-hand side. LHS equals RHS, or LHS is identical to your right-hand side, as you are required to prove. And that's it. Good?
Yeah.
All right. Okay, are we good for today? Yes? Maybe?
Yeah.
Okay. All right. Well, thanks for joining. Yeah. Hopefully you guys all got what you needed. Oh, Samir. Yeah, no problem, Yeah, of course.